Hello team, welcome back. In this section, we will learn about some real life scenarios with the Terraform. So here we are going to take our first real life example, or you can take it as a first case study. In this section, we will see how we can deploy some EC2 instances, deploy the web server on the EC2 instances, how we can deploy the RDS service, how we can deploy the load balancer and attach these load balancer with the EC2 instances. So as I told you, the discussion on this section will be on a real life job scenario, or you can say the case study, the real life case study. We'll deploy the application with the below components. In this lab, first we will deploy a virtual private cloud network. Because whenever we are going to create some application on AWS, definitely we need some VPC to take care of the network requirements. So first we will create the VPC. Then we will create the RDS service. RDS stands for Relational Database Service. In the Amazon, we can directly deploy the relational database service on the Amazon infrastructure. With the help of the Amazon RDS service, we can directly deploy the relational database service on the cloud. So we will see how we can deploy the RDS, which RDS will use the VPC which we have created before this RDS. And then we will deploy the web server which will use the VPC. Although in this lab, we are not going to connect the web server or the application server with the RDS, but we will deploy the multi-zone available RDS so that in any case, if you want to create some app server or some web server, you want to create some servers which requires the database need, then you can learn from this lecture that how we can deploy the RDS service in Amazon. So here we are listing the components of the lab which we will deploy as a part of this section. So first component will be the RDS, the primary DB with the replication. We will deploy the RDS with replication. It means this database service will be a multi-zone service. We will create the auto scaling group and the launch config for the web servers so that whenever the load will be increased, the EC2 instance will be auto scaled. And what template will be used when the node will be auto scaled? That will be the launch config. Then we will create the load balancer and we will attach that load balancer with the web servers which we are going to deploy as a part of this lab. We will deploy the EC2 instances for the web servers. We will deploy the security group for each of the resources we have defined till now, for the web servers, for the RDS service, and for the load balancers. We will define the virtual private cloud network for our RDS service and the web servers. In the VPC, we will define the net gateway and internet gateway so that these are the resources which we will create as a part of this section. Here we are creating the web servers, which is a front-end service. We are creating the RDS server, which is the backend service, and we are using our own VPC network, which will be used by the backend service and the front-end service. So team, these are the components. First, we will learn about the Terraform configuration of each component, and then we will directly see how we can deploy these component in the AWS. So thank you team. See you in the next lecture. Hello team. Welcome to Terraform training. And today we will go through the Terraform configuration code for some modules which we are going to use in this section. So let's go to the code editor and we will go through the code for the VPC. So team, we are on the code editor Visual Studio Code, and here inside the Terraform directory I have created another directory called case study #1. So this directory have the module directory and the web server directory. First, let's understand the module. So inside the module, I again have the two directories, the RDS and the VPC. First, we will discuss about the VPC. Inside the VPC, we have the two configuration file, vpc.tf and variable.tf. Let's open the vpc.tf and try to understand the resources which we are creating in vpc.tf. So in the vpc.tf, very first I'm defining a data source AWS availability zone, which will get all the availability zone of the region which I will supply to this vpc.tf. Then I'm defining my main VPC, AWS VPC. The name of my VPC will be level up underscore VPC. I'm defining the CIDR block range, and that CIDR block will be dependent on the variable called level up underscore VPC CIDR block. The DNS support is enabled. The DNS host name is also enabled. Inside the tags, I am creating the VPC tag which will be dependent on the variable environment. So this will create the tag like environment hyphen VPC. It means if I will supply the environment variable name development, then the tag will be development hyphen VPC. If I will supply the environment variable like production, then the tag will be production hyphen VPC. Then we are defining few public subnets. We are defining first public subnet level up underscore VPC underscore public underscore subnet one. I'm taking the VPC ID from the our VPC, defining the CIDR block on the basis of the variable, taking the availability zone on the basis of the availability zone which I have defined over here inside the data source. See, we are taking data AWS availability zone availability dot available zone 1. It means the zone 1 will be supplied in the availability zone of the region which I will supply to this vpc.tf. Map public IP on launch. I'm creating the public IP on launch true and taking the tag environment hyphen VPC public subnet 1. So for the development, the name or the tag name for the VPC public one is the development hyphen level up hyphen VPC hyphen public hyphen subnet hyphen 1. The similar kind of code we are defining for the second subnet, right? But the availability zone is different. Earlier we was taking the 0th index value. Now I'm taking the first index value. Then we are defining the public. Then we are defining the private subnet. And first private subnet I'm defining inside the availability zone 0. Then we are defining the another private subnet and the zone is 1. After this, we are defining the internet gateway. This internet gateway will be used by the VPC to communicate via internet. So I'm defining AWS internet gateway level up hyphen level up underscore IGW. The VPC ID I'm taking from the VPC which I have defined over here, and the tag I'm taking from the environment variable. Then we are defining the net gateway to connect with the EIP. Then we are defining the EIP. Over here, VPC will be true and it will depend on the internet gateway which we have defined over here. So this elastic IP for the net gateway will be dependent on the internet gateway. Then I'm defining the net gateway. So AWS net gateway. The name of the net gateway will be level up underscore NGW. In the allocation ID, I'm defining the ID of my EIP. Subnet, I'm creating this net gateway in the public subnet one, right? And it will depend on the internet gateway. See, it is depend on the internet gateway which we have defined over here. Then similarly, which we have created earlier, we are defining the public routing table and we are defining the private routing table. Then we are defining the public subnet association with the public route table, right? And the private subnet association with the private route table. Then we are taking the AWS provider. We are taking outputs like my VPC ID, public subnet 1 ID, and sorry, private subnet 1 ID and private subnet 2 ID, public subnet 1 ID and public subnet 2 ID. So these are the resources. This is the Terraform configuration file which we are creating for the vpc.tf. I'm pretty much sure that the same kind of configuration we have seen multiple times during this course, because we have created the vpc.tf multiple times. Sometimes we have created the vpc.tf with the custom configuration by which we are creating in this lab. Sometimes we have created the vpc.tf from the module which is registered on the register.terraform.io. Let's go through the variable.tf. Inside the variable.tf, we are taking all the variables which we have defined inside the vpc.tf. So we are taking AWS region. We are also defining the default value for some variables. We are taking the CIDR block for the VPC. The default is 10.0.0, CIDR block 16. CIDR block for the public subnet 1, public subnet 2, private subnet 1, private subnet 2. The CIDR block is 10.0.1.1, 1.2, 10.0.1, 10.0.2. Then we are taking the environment, and environment, the default environment is development. So this is the first module which we are defining as a part of this lab. In the coming lecture, we will discuss about the RDS. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And today we will discuss about the another module of this job scenario, which is RDS. So let's go to the code editor and let's see what is the Terraform configuration we have created for the relational database service in Amazon. So in the last lecture, we have discussed about the VPC. I'm going to close this variable.tf and open the RDS. So I've defined another module RDS, and RDS again have the two files, rds.terraform file and variable.terraform file. Let's open the rds.tf first. In the rds.tf, what we are doing first we are calling the level up module, right? You can see over here I'm defining the module level up VPC, and I'm defining the source, which is a VPC from the exit of this directory. So as soon as I will put double dot, this will go to the exit, and at the same level we have the VPC directory. And to the VPC module I'm providing two variables, variable.environment and variable aws underscore region. Then we are defining the resource AWS DB subnet group. This subnet group I'm defining for the RDS service. The name of my DB subnet group is level up RDS subnet group. The name of this particular subnet group will be the name on the environment, then hyphen level up DB subnet. Description, let's leave it. And inside the subnet, I'm defining both of my private subnets. And how I'm taking these private subnet? I'm taking these private subnet from the module level up VPC, and from the module I'm reading the output variable. You can see inside the VPC module we have defined the private subnet as the output variable, private subnet ID 2 and private subnet ID 1. So I'm taking the same output variables over here. Then we are taking the tags. Tags is again based on the variable environment. So here we have defined the subnet, which VPC subnet my database service will be used. So this subnet we have defined, and this is only using the private subnet, so that no user which is using the private subnet can access my database. Only the internal services which are using the private subnet can access my DB service. And I'm defining the security group for the level up RDS. It means the RDS service. So the name of my security group will be the environment name, which I will supply hyphen level up RDS SG, description created by the level up, and the VPC ID for the security group. This will use the VPC ID which is being created as part of the module. Then we are defining the ingress and the egress. I don't need to explain ingress and egress again and again, as this is a database service and I'm going to execute the MySQL database in the RDS. RDS provide the different options, but we are going to use the MySQL. So that I have defined 3306. So MySQL will accept the traffic to 3306 and will forward the traffic to 3306. The CIDR block for the database, I'm taking it from the variable. In the egress, I'm defining all protocols from all port to all port. The tag will be similar, environment, then the level of RDSSG. And then finally, I'm defining the resource AWS DB instance. So to create the RDS service, you need to create the resource AWS DB instance. And I'm taking my RDS name level up RDS. First, I'm defining the identifier. Identifier means the name of your DB instance. That is going to be the environment name, then hyphen level up RDS. Then I'm taking the allocate storage. Allocate storage means the size in GB, the size which you want to define for your database. That I'm taking from with the help of a variable. The size type, the storage type, I'm taking general purpose 2. Then the engine, which engine, it means which DB engine we are going to use in this particular DB instance. Again, I'm taking it with the help of the variable. Engine version, this is again going to be the DB version. I'm taking it from the variable. Instance class, which class instance I want to use. I want to use T3, I want to use T2, I want to use some other instance class. The backup retention period, what is going to the backup retention period? Generally by default it is a 7 days. If you want to increase it, you can increase it. Publicly accessibility, we are going to define the publicly accessibility for this DB instance. That is again going to take from a variable. The username of your database, the password of your database, and the VPC security group, which security group will be assigned to this particular RDS. So I'm taking the security group which we just created over here, right? This is the security group, level up RDS SG. Then the DB subnet group name, right? Which subnet this particular DB will be used. So subnet we have also created, and this have the ID of the private subnet only. Then multi AZ, it means multi availability zone. By default, I'm taking it false, but if you want, you can take it true. It means once you will take it true, it will create the single instance of your DB, plus it will also create the replication instance of your DB. right? And that replication instance will be in some another zone. It means if the primary instance is being launched in US East 2A, then replication instance will not be used US 2A. That may be used 2B, 2C, 2D, but it will not use, never use US East 2A. Why this AZ will helpful? Why we are taking it, and why we are calling it multiple availability zone? It means suppose in any case if any zone will go down, right, either the replication or the primary one, then we have one instance to serve the traffic, we have one instance to recover the data. That's why it is called multi availability zone. It means the machine is available in the multiple zone. So one machine is the primary machine which is interacting with the application, and another one is the replication machine on which the replication is being happen from the primary machine without any lag. Then we are defining the output, and in the output we just have the RDS endpoint. Let's go to the variable. In the variable, we are defining the AWS reason, the backup retention period, which is 7 days, publicly accessibility, which is true. Level up RDS username. This is the name of your DB. This is the username of your DB, which is test DB. Level up RDS password. This is the password for your DB. Please make sure we are not going to use at the rate, hash, and exclamation because that are the reserved characters. We are going to allocate the storage. The storage I'm defining is 20 GB. The RDS engine, I'm taking the engine MySQL, and the RDS engine version, I'm taking 8.0.20. At the time, whenever I'm creating this lecture, the 8.0.20 is the latest MySQL engine which is available on the AWS. If you want to change it, you want to go to some lower version like 5.7, right? You can change it. If you want to go to the higher version, then you need to check with the AWS that is the higher version available on AWS or not. And if it is available, then you can definitely change this RDS engine version. We are taking the DB instance class. I'm taking it db.t2.micro. You can take it anything, right? You can go to the AWS account and you can search. Then what are the instance class are available? We are taking the CIDR, which is 0.0.0 with the CIDR range 0, and we are taking the environment, which is the development. So this is the complete configuration of the RDS. It may possible that some people may face some issue to understand this configuration. So what I will do, I will show you how AWS configuration will look like on the AWS console UI. So I'm on my AWS management console and I will click on the RDS service. If you unable to find out the RDS service, you can click on the services and find out the RDS. Right here we are getting the RDS service. I will click on it. You can see we are allowed to create the 20 DB instances and 40 DB cluster. Nothing is executing in my DB instances. Let's create database. We are taking standard create or easy create. I'm going with the default option, and we have the different kind of engines. We have the Amazon Aurora, MySQL, MariaDB, PostgreSQL, Oracle, and most and Microsoft SQL Server. So I'm going with the MySQL. The MySQL, you are getting the engine versions. I have taken 8.0.20, which was the default, but we are getting the earlier version listed as well. So you can take the MySQL engine version as per your application need. The template, it is going to production, dev test, or free tier. Let's go with the free tier. You need to define your DB instance identifier, which we have defined. You need to define the username, master password, confirm password, and you can see we are taking the DB instance size. We have took db.t2.micro. We are getting the different options as well. Other options are basically not eligible for the free tier. So if you will go with the production, you can see we are getting the different options as well. db.m5, db.m5 extra large, 4x large, 12x large, 6x large, and here we are getting the 64 CPU, 256 GB RAM, the configuration as well, right? And the network bandwidth of these machines. That this is the highest configuration machine, which is 96 CPU, 284 GB RAM with the network 19,000 megabyte per second, right? So this is the capacity, this is the bandwidth which we can use on this machine. I'm not going to create this much of heavy machine because they will cost me a lot. I will go with the free tier. And for the free tier, we have the only option db.t2.micro. We are getting the storage type. We have taken general purpose 2, which is GP2. The default size is 20 GB. Enable storage auto scaling. Maximum storage threshold 1000 GB. Multi availability zone is not available for the free tier, so that I have make it false in my Terraform configuration file. Here we are getting the VPC, which VPC you want to use. This is the default VPC. We are getting the subnet group, which we have defined inside the Terraform configuration file. We are getting the VPC security group, which we need to choose. In our case, we have already defined the VPC security group inside the Terraform configuration file. Password authenticator and the password and AMI database authenticator, these are the database authentication services. We are taking password authentication so that we have defined the password and username in my configuration file. And that's all. Once you go with the create database, it will create a database for you, right? So the same thing which we are going to supply on the UI, we have taken all the things in the Terraform configuration file for the RDS, right? So this is the configuration file for the RDS module. In the coming lecture, we will discuss about the web server configuration, and in the web server configuration we will see how we will use the RDS and the VPC module as well. So thank you team, see you in the next lecture. Hello team, welcome back. Welcome to Terraform training. In last lecture we have discussed about the RDS module. Today we will see the module web server, and we will see how we can use the RDS and VPC in the web server modules. So let's go to the code editor. So yesterday we was discussing about the rds.terraform configuration file, and we have already seen the UI parameters from AWS Cloud Console for the RDS. Today we will discuss about the web servers. So in the web servers, we have few files. We have the variable.tf, web server ALB, and web server instance. First, let's discuss about the web server instance. So in first web server instance, we are defining two modules. First module we are defining for the VPC, and second module we are defining for the RDS. It means whenever we will start using the web server, right, it will use both of the modules and it will create the resources which is being defined inside the RDS module and inside the VPC module. Then we are defining a security group. This security group name is same as we are using the same convention since RDS and VPC. We are taking the environment, then some custom value. Over here we are taking environment name, then level up web servers. The VPC ID I'm taking from the module level up hyphen VPC, my VPC ID. So in the VPC module, if you remember, we have defined the output my VPC ID. I'm reading the same output over here. The ingress is port 22 TCP protocol, and CIDR block I'm taking from the variables. I'm defining another ingress on port 80, which is again TCP protocol, and it will accept the traffic from all IPs or all users. We have the third ingress over here on port 443. So on port 22, the ingress is basically the SSH connection, right? SSH connection will be created on port 22. On port 80, we will accept the HTTP traffic because HTTP traffic by default land on port 80, and 443 is for the HTTPS. If you want to put the secure domain, then all the HTTPS traffic will be redirected to port 443, so that we are using the 443. We are using egress network from port 0 protocol -1. It means all the port to all the port protocol, all the protocol to the all IPs. This is the security group we have defined. After the security group, we are defining the key value pair, which we are defining since long. Over here we are taking the path from a public key variable. Then we are defining the launch configuration, right? We have already discussed about the launch configuration in the earlier lectures. Launch configuration we need to define whenever we are creating the auto scaling group, so that with the help of the launch configuration, auto scaling group can scale new nodes in the system. And whenever a new node will be launched, this launch configuration will be used as a template. So I'm defining a launch configuration. This will take the image ID from the AMI's variable on the basis of the reason. This is the lookup function, we are already aware it. Instance type I'm taking from the variable, and this is also have the user data. Inside the user data, you can see first we are updating the packages, then we are installing the NetTools and Nginx. After this, we are reading the machine IP with this particular shell command, and then we are putting a message echo hello, then a new line, this is my IP, and I'm printing the IP which I redirected. And this all message we are basically putting inside the file html file index.html, which is present inside the where www.html. So this is the user data we are supplying to this template. The security group we are using is the security group which we have defined at above side. The key name, this is the key name we are using over here. Root block side, we are taking the volume type GP2 and volume size 20. So this is the launch configuration. This is the simplest code. We have already discussed about it. Then we are defining the auto scaling group. Why we need the auto scaling group? If you remember, then we have discussed about the auto scaling group, where we have seen the auto scaling and auto descaling with the help of the stress tool in the same course, right? So I don't need to explain the function of the auto scaling group. I'm just defining the properties. Name of the auto scaling group will be level up underscore web servers. Max size will be 2, min size will be 1, health check grace period will be 30 second, health check type will be EC2 type, desired capacity is 1, force deletion is true. Launch configuration, the launch configuration we defined over here, right? The same launch configuration is being used inside the auto scaling group. VPC zone identifier, over here we are taking the public IP1 and public IP2. Target group ARN, over here we are taking the ARN of the load balancer. We have defined the load balancer inside this configuration file, so we will discuss about it. Then we are defining the another resource, AWS load balancer. The name of the load balancer will be environment level up hyphen LB. The load balancer type is application load balancer. The security group which we are using over here, that is being defined inside the web server alb.tf. The subnets, I'm using the public subnet 1 and the public subnet 2. Then we are taking few target group. So we are taking AWS load balancer target group, and inside the target group we just have the name, the port, the protocol, and the VPC ID. The HTTP listener for the AWS load balancer is the AWS LB, then the load balancer ARN. See, it is taking this particular load balancer ARN, port 80, protocol 80, protocol HTTP. And inside the default action, we are taking the target group ARN, which is the load balancer ARN we have defined inside this particular file. Then we have the output, load balancer output, right? Let's go to the web server.alb.tf. And over here, you can see we are defining the AWS security group, right? This is the security group for the ALB. This have the ingress on 80 TCP, 443 TCP, output, egress, or port to all port -1 for all the IPs. Then inside the variable, we have the few variables, the CIDR block, which we have defined inside the web server instances, instance type, AMIs on the basis of the zone, AWS region, environment, and public key path. We have two more files over here outside the web server, main.tf and the variable.tf. Let's discuss the variable.tf first. Inside the variable.tf, we have the few variables like the environment, the AMIs, AWS region, and the instance type. We will go to the main.tf. The main.tf is using only module web server and the provider. So what will happen once I will execute the Terraform apply at this location? This will call the module web server. Web server module will call the modules VPC and the RDS, right? So that my complete resources which I have defined inside these modules and this web server all will be created in a one go. So let's close this lecture over here, and in the coming lecture we will see the deployment of all the resources with the single Terraform command. So thank you team, thanks for your time. Hello team, welcome to Terraform training, and today we will see how we can deploy all the resources which we have discussed in this section. So we will deploy the web server, we will deploy the RDS services, VPC, and the other resources which we have defined inside the Terraform configuration file. So let's go to the machine where we are executing the Terraform. So we are on this machine, let's go to the directory Terraform, and over here we will get the git pull. So I might already get the git pull so that I'm getting already up to date. Over here if we will put ls, then you can see we are getting the folder case study #1. We will go to this directory, and if we will put ls, we have the main.tf, module, variable.tf, and the web server. Suppose we will go to the module, put ls, then we have the RDS and VPC. Let's go back to the earlier directory, which is case1, right? And over here let's execute Terraform init. So you can see it is initializing the module, initializing the backend, and the Terraform init is done. Now let's execute Terraform plan. Once we will execute the Terraform plan, we will get to know that how many resources this particular configuration is going to deploy on the AWS. And as per my configuration, total 25 resources will be added as a part of this deployment. So let's see what are these 25 resources. So first it is going to deploy the net IP, internet gateway, net gateway, private route table, public route table, then the private subnet association of private subnet 1 and private subnet 2, public subnet association for the public subnet 1 and public subnet 2. Then it is going to deploy the private subnet 1, private subnet 2, public subnet 1 and public subnet 2. Then it will deploy the level up VPC. It is going to deploy the web server, the level up key, launch configuration, load balancer, web server listener, load balancer target group, security group for the web servers, security group for the ALB, application load balancer. Then it is going to deploy the RDS service. And if you want to see that we are getting all the resources, we are getting the retention period, we are getting the allocated storage, the engine version, the same thing we have defined inside the configuration file. Then it is going to deploy the subnet group for the RDS, the security group for the RDS, and that's all. So total 25 resources will be added as a part of this deployment. Let's clear out the console and execute Terraform apply. I would like to make sure that my username and my password, the AWS access key and AWS access ID are stored in the environment variable. So I don't need to supply the environment variable or the access key in the configuration file or during the command execution. Once I will hit the Terraform apply, it will take some time and it is asking permission to deploy all 25 resources. Let's hit enter and we are deploying all these resources in US East 2. So see, it is deploying the resources. Now it is creating the web server. We have to wait until all of the resources will be created and RDS service will take long. RDS service may take up to 6 to 7 minutes to deploy the complete database. So we have to wait until the complete resources will be created on the AWS. In the meantime, we can go to the AWS and we can verify the resource creation. So we are on the AWS. First, let's go to the VPC and verify the resources are being created in the VPC or not. So we are getting the two VPCs. Let's open the VPC. And yes, my VPC is being created because my VPC name is on the basis of the environment and I'm supplying the development environment. And CIDR block is also matching, which I'm supplying via variable 10.0.0 CIDR block 16. If we will go to the subnets, we are getting the development level of private subnet and the public subnet. In the route tables, we are getting our route tables, the private route table and the public route table. Each route table have the two associated subnets. If we will go to the internet gateway, this is my internet gateway which we deployed, right? Development level up VPC internet gateway. If we will go to the elastic IPs, we will get all elastic IPs. So this EIP is basically being created. If we will go to the net gateway, the net gateway is also deployed, which is development level up VPC net gateway. If we will go to the security groups, then my security group are also being created. Level up web server ALB security group, web server security group, and the RDS security group. Let's go to the EC2. One instance is running, and if we will go to the tags, yes, this is my instance, right? If we will go to the load balancer, then one application load balancer is also running. Here we are getting the load balancer DNS name and the other things, the listeners which we have associated with this load balancer, the monitoring, integrated services, and the tags. If we will go to the RDS service, you can see we are getting 1 DB instance, and this is my RDS service, development level up hyphen RDS. Let's open it, and this is creating in the baking up. If we will go to the machine where we are executing the Terraform, then you can see it is still executing and it is creating that AWS DB instance level up RDS is still creating, and it's creating the resource since last 4 minutes. Over here, if we will verify this endpoint, then you can see this is the zone US East 2A. This is the VPC development VPC which we have associated. These are the subnets. These are the security groups. In the monitoring, we will get the monitoring of the DB. In the logs, we will get the logs. Let's go to the configuration and let's verify the configuration as per our given configuration or not. So this is the instance ID, the engine version which we have supplied 8.0.20. This is MySQL 8 which we have supplied. Instance DB class which we have supplied. Master username is testdb which we have supplied. And the storage is 20 GB which we have supplied, right? So these are all the things we are getting which we have supplied during the creation of this DB. Maintenance backup, here it is auto enabled. In the tags, we are getting the tag and we don't have any tag on the RDS. It will apply the tag once the creation will be successful. So let's wait until the creation will be done. We'll go to the Terraform machine again, and it's still creating. 5 minutes is already done. You can see the resource creation is done and we are getting the output of the load balancer. If you remember, then inside the launch configuration, we have installed the Nginx and we have installed the netstat. With the help of the net tools, we got the IP of the machine and we have printed that IP inside the index.html. By default, Nginx is installed on my machine. So if I will copy this load balancer and go to my browser, I will put it here, hit enter. Then you can see I'm getting the message. Hello team, this is my IP 10.0.2.237. If you will go to the EC2 instances, then you will identify that this is the IP, the internal IP of your machine. I will click on my instance. See, this is the private IP of my machine 10.0.2.237. The same IP I'm getting over here. Let's hit it again and again, and we are getting the same IP. So we have seen that all the resources created and all the deployment is successful. Now what we will do, we will go to the database, we will go to the actions, and we will click on the delete. Over here, we will uncheck this. We will check this acknowledgement checkbox and type delete me and delete my database. This deletion will take some time. You are getting the progress over here. Why I am deleting the database from the AWS console? Because once you will destroy the database from the Terraform, AWS by default don't destroy the database in that way. It will ask to create the snapshot and that permission is not being handled by the Terraform till yet. So that I'm deleting the database from the AWS console. Otherwise, your Terraform destroy will be failed. Now I will go to the Terraform machine and I will execute Terraform destroy. Hit enter. It will ask for the confirmation. I will provide the confirmation. You have to wait until all of the resources is being deleted. If this destroy will fail, you need to wait until the database will be deleted and then you need to execute the destroy again. So we have seen our first case study. In coming lectures, we will see some more practical labs on the real life scenarios. Thank you, team. Thanks for your time. Hello, team. Welcome back. Welcome to Terraform training. And this is the another section where we are learning few more real life scenarios or the case studies. So in this section, we will learn about the AWS EKS. EKS is the Elastic Kubernetes Cluster. So we will learn how we can create the Kubernetes cluster in AWS and how we can create the Kubernetes cluster in AWS with the help of the Terraform. So let's start with. But before going with the deployment, first try to understand the Kubernetes cluster in a quick way. So Kubernetes is a quickly become the standard way to manage application containers in the production environment. So if we are executing the application in the Docker container, then Kubernetes is the orchestration tool which can be used in the production to manage the Docker containers. And Kubernetes become very successful in last few years. Even today, 90% market is asking for the Kubernetes as a mandatory skill set in DevOps. Kubernetes is configurable on cloud machines, on-prem machines. So as I believe almost all public clouds or the all major public clouds are providing the Kubernetes as an inbuilt application. Google provide the Google Kubernetes engine, AWS provide the Elastic Kubernetes engine, Microsoft Azure also provide the inbuilt Kubernetes engine, and Kubernetes is also an open source. If you want to install the Kubernetes on your on-prem machines or on your own servers, you can directly install the Kubernetes on your own servers or the on-premise machines and you can use it. But the challenge with the on-premise Kubernetes configuration is the Kubernetes cluster management. So whenever we are going to create our own Kubernetes cluster in the on-premise system, we need to manage the Kubernetes cluster. Whenever we are going to create the Kubernetes cluster on the public clouds, like we are using the inbuilt application, Kubernetes application like EKS on the AWS, GKE on the Google Cloud, then the administrator work or the administration responsibility is the public cloud's responsibility. You don't need to manage the Kubernetes cluster, you just need to focus on your application. Kubernetes administration and configuration is a bit complex. Kubernetes is an open source technology which is introduced by the Google, right? So initially Google used the Kubernetes for their own development, but somewhere in between 2015 and 2016, Google makes the Kubernetes as the open source project, right? So Kubernetes will open for the public use and since then Kubernetes become a popular tool for the Docker orchestration. Amazon Elastic Container Service for the Kubernetes called the Amazon EKS, which makes the Kubernetes cluster setup easy and quickly deployable. If we are using the Amazon Elastic Kubernetes service, then we would be able to set up the Kubernetes service within 10 to 15 minutes. But if you are going to configure your own Kubernetes cluster and you don't know about the Kubernetes cluster configuration, then it may take up to 5 days or 7 days to set up the successful Kubernetes cluster, which will be useful for the production machines. Let's understand few benefits of the AWS EKS. So Amazon EKS service runs the Kubernetes management infrastructure across multiple AWS availability zone, thereby freeing user from maintaining the Kubernetes control plane. So whenever we are deploying the Kubernetes cluster in AWS automatically manage the infrastructure in the multiple availability zone. So that in any case, if AWS faces single zone failure, then the another zone will support the application. Infrastructure running on the Amazon EKS is secure by default by setting up the secure and encrypted communication channel between the worker nodes and the Kubernetes endpoint. So Kubernetes work in a worker and master process, right? You have the master node and you have the multiple workers node. The communication between the master node and the worker node will be done by the Kubernetes VPC, which is already a secured cloud network. So AWS provide the secure infrastructure for the Kubernetes, which will provide the secure and encrypted data flow between the master and the worker nodes. Applications managed by the Amazon EKS are fully capable with application managed by the standard Kubernetes environment. So all the features which you will get in the standard Kubernetes environment, these all features will be available in the Amazon EKS. Plus, there is a benefit with the Amazon EKS that you will get the security and the features of the Amazon. So along with the Kubernetes functionality, you are also getting the AWS features. That is the plus point with using the Amazon EKS instead of the standard Kubernetes environment or standard Kubernetes clusters. So let's understand how does the EKS works. So in Amazon, first we will provision the Amazon EKS cluster. Then we will deploy the worker nodes. Then we will connect to the EKS cluster and then we will execute the application. So first we need to create the EKS cluster in the Amazon. Then we need to deploy the worker nodes. These worker nodes are the EC2 instances which will connect to the Amazon EKS cluster with the help of the EKS endpoint. Then whenever we are going to execute the application on the EKS, then first we need to connect on the EKS and then run the applications on the EKS. So this is the complete workflow of Amazon EKS service. In the coming lecture, we will see how we can deploy the Amazon EKS and how we can deploy the Amazon EKS with the help of the Terraform. So thank you team. See you in the next lecture. Hello team. Welcome to Terraform training. And today we will see a lab that how we can deploy the AWS EKS cluster. So first we will deploy the AWS EKS cluster with the help of the Amazon console. And then we will deploy the Amazon EKS cluster with the help of the CLI. So why we are going to deploy the Amazon EKS cluster with the help of the console? Because I would like to explain you the parameters which you need to supply to the EKS cluster so that whenever we are going to deploy the same thing with the help of the CLI or with the help of the Terraform, so that seems familiar to you. And you will be easily able to understand that what parameter we are supplying in the Terraform configuration. So first go to the Amazon console and try to deploy the EKS cluster with the help of the Amazon console. So I have logged in my Amazon management console. And over here, I need to go to the region where I want to deploy the EKS cluster. So suppose I want to deploy the EKS cluster in EU West 1, which is Ireland region. So I will switch to the Ireland and I will search for the EKS. You can see we are getting the Elastic Kubernetes service. I will click on it. And right now, none of the EKS service is running. If we will go to the clusters over here, you can see no Kubernetes cluster or EKS cluster is running on my Amazon. Team, please make sure that although we are using the free account, but Amazon EKS cluster will charge you at least 20 cent per hour. So we are going to create the EKS cluster, but as soon as we will complete this lab, we will directly delete that cluster so that we will not get the billing. So if you want to create a new cluster, you can directly go to the create cluster button. But before going to create the Kubernetes cluster, we need to create some role which will be helpful this account to create the Kubernetes cluster. So we'll go to the services and I will go to the IAM roles. In the IAM, we will go to the roles and we will create a new role. So over here you can see we are getting select type by the trusted entities. I'm going with the AWS services. Then it is saying to choose use case. And over here inside the services, we are getting all services which are the part of the AWS. Here we are getting the EKS. I will select the EKS. Now once you will select the EKS, we are getting few use cases like EKS, allow EKS to manage cluster on your behalf. EKS cluster allow access to other AWS services resources that are required to operate cluster managed by the EKS, and few other options as well. I will go with the first option, which is the EKS allows EKS to manage cluster on your behalf. Go to the next permissions. Here we are getting the Amazon policy. If you will open this policy, then this policy is basically Amazon EKS service role policy, and here is the JSON of this particular policy. If you want to create it from the Amazon CLI, you can use this JSON. I will go next, which is tags. Then I will go to the review and I will create the role. So I've created the role AWS cluster role for EKS. I will create another role over here. Click on the EKS, and in all these possible solution, I will go with the EKS cluster. Click on next permissions, and you can see here we are getting the EKS cluster policy. Click on next tags. Here, if you want, you can provide some tags. I'm providing the role EKS. Next review. You need to put your role name. Suppose I'm putting it AWS EKS, right? And create the roles. So we have created the role called AWS EKS. Now after creation of this role, we need to go to the services again, and we need to go to the Elastic Kubernetes services. Here we need to go to the clusters. We need to go to the create cluster button. We need to provide the EKS cluster name. I'm providing like level up hyphen EKS. We are getting the Kubernetes cluster version, which version we want to deploy. Suppose we are going with the default one. And over here you can see we are getting the cluster role services, and over here EKS AWS EKS is already selected, which we just created. If this role is not coming here, you need to go to the drop down and you need to select it. Then it is asking for the secret permissions. I will keep it default disabled. It is asking for the tags. I will provide some tag like environment, call it development. Click on next. You can see here it is getting the VPC. If you want to use some specific VPC, you need to use that VPC. After the VPC, you need to select the subnet of that particular VPC. Here each subnet belongs to the different availability zones, right? If you want to check, you can go to the VPC and you can verify the subnets which are being listed over here. They belongs to the different availability zones. Inside the security group, if you have some security group, you can choose it. If you don't have any security group, you can leave it as well. Cluster endpoint access, I'm keeping it public. If you want to make it public and private, you can go with your choice. Networking add-ons, I'm not going to put up any networking add-ons. So I'm going to put the Amazon VPC CNI, right? And the version which I'm using is the latest version, which is being already selected. Click on next. Then it is saying, do I need to enable the API server, audit logs, authenticator, controller messenger, and the scheduler? You can open the options as per your need. So suppose I'm going with the schedulers and the API servers. If you're not able to understand the what are the API servers and the what are the schedulers and the control managers, you need to learn about the Kubernetes, right? In some other course, we have explained the Kubernetes as well. So we have the another Kubernetes masterclass course as well. If you want to learn about the Kubernetes, you can enroll these courses. Then inside the review and create, you can review your cluster configuration and click on the create button. This will take some time. It may take up to 4 to 5 minutes to create the Kubernetes cluster. We have to wait until the Kubernetes cluster will be ready. So team, we can see now our EKS cluster is active state. We don't have any worker nodes with this EKS cluster. So we are getting the nodes 0. If we will go to the workload, then we can see we have the core DNS, we have the AWS node and proxy, and the created 5 minutes ago all. Right now 0 pods are running. No pods are right now 0 pods are running. It means no pods are running in my Kubernetes cluster. If we will go to the configuration, then this is 1.18 version. EKS3 platform is being used. The details, we are getting the API server endpoint, we are getting the OpenID connector provider URL, we are getting the cluster ARN as well. Here I'm getting the ARN of the roles which is being attached with this cluster, and the certification authority is being copied from this location. This is the creation time. The secret encryption is disabled. If we will go to the compute, no worker nodes is basically attached with this cluster, so that we are getting the zero nodes group and zero forget profile. Inside the networking, we are getting the VPC, the VPC ID, and the subnets which is being used. In the add-ons, we have the VPC CNI add-ons. In the logging, we are getting the API server is enabled, authenticator is disabled, scheduler is enabled, controller message is disabled, and audit entry is also disabled. In the update history, we have not updated this cluster yet, so we are getting updated history 0. And in the tags, we are getting the tag which is being attached with this cluster. So here we are getting the complete information of my cluster. And this is the way how we can create the Kubernetes cluster with the help of the Amazon Management Console. Please make sure the Kubernetes cluster creation may take time. When I'm creating this cluster right now, this took more than 7 to 8 minutes. So you have to keep patience whenever you are creating the Kubernetes cluster. Once the cluster is ready, you can see the cluster is active, right? Now what I need to do, I just delete this cluster. So I will click on the delete and type my cluster name, which is level up hyphen EKS. Click on delete. So I will delete this cluster and I will not get the extra charge on my free account. And over here we are getting the highlighted message as well. Level up EKS is now being terminated. This process may take several minutes, right? So this is the way how you can create your own Kubernetes cluster in AWS and how you can terminate your cluster. In the coming lectures, we will see how we can create the EKS cluster with the help of the AWS CLI. So thank you, team. See you in the next lecture. Hello team, welcome to Terraform training. In last lecture, we have seen how we can create the EKS cluster with the help of the AWS Management Console. Today we will see how we can create the EKS cluster with the help of the CLI. So we are going to use the Amazon CLI to create the AWS Kubernetes cluster. So let's go to the machine where we are executing the Terraform and let's see what is the prerequisite we need to follow and how we can set up the EKS cluster with the help of the EKS. So we are on the machine where we are executing the Terraform, and this machine is the Ubuntu machine. As we are going to set up the AWS cluster with the help of the CLI, so it means we are going to execute few commands with the help of the command line. So if you are using the Ubuntu machine, you can follow the simple commands which I am going to execute over here. If you are using the CentOS or the Mac machine, you need to go to the Google and find out the documentation to install the few things. So as a prerequisite, we are going to install few things. First, we will install the AWS CLI. Then we will install the kubectl, which is kubectl, and then we will install the AWS IAM authenticator so that we can authenticate with the Kubernetes cluster. So first we will see how we can install the AWS CLI. So to verify that the AWS CLI is installed on your machine or not, you need to execute a command AWS hyphen hyphen version. In my case, this command will return some version because AWS CLI is already installed on my machine. But in your case, if you have used the AWS CLI in past, then it will definitely return the version. Otherwise, this command will show the error. In both cases, either the AWS CLI is installed on your machine or not, we are going to install the fresh AWS CLI. So first check which version I'm using right now. So I'm using AWS CLI 2.1.13, right? But I'm going to install the latest version of the AWS CLI. And to install the AWS CLI, we are going to execute this command, curl. Then we will specify the URL from where we will download the AWS CLI zip file. And with the help of the -o, I am going to rename the AWS CLI zip. So I'm downloading the AWS CLI Linux 86 underscore 64 zip, and I'm going to rename it AWS CLI v2.zip. Hit enter. This will download the zip. The total size of 33.5 megabyte is being downloaded on my machine. If I will put ls, you can see the zip is here. Now we will unzip this zip. So I will use a command unzip, then the zip file name. This will unzip your zip, clear out the console, put ls again, and you can see we are getting the AWS folder over here. Then we will execute sudo.aws install, and when I'm executing the AWS install, we are getting a message found pre-existing AWS CLI installation. It means AWS CLI is already installed on my machine. In your case, you will not get this message, right? You will get the AWS installation message. If I want to update it one more time, I will execute it update. And once I'm executing this with the update, we are getting a message, you can run AWS local bin AWS. And once I'm executing sudo AWS install hyphen hyphen update, I'm getting a message, you can now run user local bin AWS version. Let's execute AWS hyphen hyphen version, and you can see the version is being updated. Earlier the version was 2.1.13, now we are getting 2.1.14. So this is the way how you can install the AWS CLI on your machine. Next installation we need is the kubectl. So first we will download the kubectl. So we are going to execute this command curl-o kubectl, and then we are going to pass the URL from where we are going to install the or download the kubectl. Let's hit enter, and this will download the file kubectl. So you can see download is in progress. We have to wait until the complete download will be done. So download is completed more than 70% and it's 100% downloaded. Hit ls, and you can see we are getting the kubectl over here. Now we will provide the executable permission to the kubectl content or directory. So we will execute chmod +x, then the kubectl complete directory. Put ls, and you can see executable permission is supplied to the kubectl. After this, I will move the kubectl to the user local bin. So we'll execute a command sudo mv kubectl. Then we will provide the path where we want to move it, user local bin. Hit enter. Put ls. You can see the kubectl is being moved to the user local bin and it is not present in the current directory. Once you will move the kubectl to the user local bin, we can directly verify the kubectl version. To verify the kubectl version, we will execute a command kubectl version hyphen hyphen short hyphen hyphen client. This will return the kubectl client version, which is version 1.18.9 EKS. So we have successfully installed the two things. First, we have installed the AWS CLI. Then we have installed the kubectl. Now what is next we need to install? Next we need to install the AWS IAM authenticator. So first we will download the authenticator, and to download the authenticator we are going to execute a command curl-o AWS IAM authenticator, which is the name of your file, and I'm going to download the authenticator from the given URL. Don't worry, I will supply all these commands which I'm executing over here as a text in the coming lectures, so that you can also execute the same command to do your lab. If you will put ls, you can see AWS IAM authenticator is basically being downloaded. We will provide the executable permission to the AWS IAM authenticator. Put ls, permission is being provided. Now we will move the AWS IAM authenticator to the user local bin. So we'll execute sudo dot AWS IAM authenticator, and we will move it to the user local bin. I forgot to mention the move command, so I will put sudo mv. Hit enter. This is being done. Now what I will do, I will verify the AWS authenticator help. So let's put AWS hyphen IAM authenticator help. Hit enter, and you can see we are getting the authenticator help available. It means AWS authenticator is installed on my box. So we have done all the prerequisite. We have installed the CLI, we have installed the kubectl, we have installed the authenticator. Now let's clear out your console and create a command which you can use to create the Kubernetes cluster on your AWS. So before creating the AWS, first we need to create the role. And if you remember, in last lecture we have already created the AWS EKS cluster role. If you have not created that role, you need to create the AWS EKS cluster role as we have created in the last lecture. Once the role will be created, we need to create the VPC. So we need to create the VPC which can be used for the EKS. So to create the VPC, we will go to the AWS management console. That is not required to create the separate VPC, but it is a good practice for the lab. I am showing you to create the separate VPC for the AWS so that you can make your AWS cluster network separate from your regular network. I will go to the AWS management console and log in my account. Once you will log in your account to, so there could be the multiple ways in AWS to create the resources. The one way, we can directly go to the resources, we can go to the VPC, then we will create the VPC, we will create the subnets, we will create the firewall rules, we will create the routers, route tables associations, right? And second way is we can use the cloud formation functionality of the AWS. In the cloud formation functionality of the AWS, we need to supply the JSON format, which is a file, and as per the data defined in that particular file, AWS will create the resources for me. So over here, first we need to switch to the resource or region where we are going to create the resources. So let's go to the US East 2 and first verify how many VPC are running in the US East 2. So there are two VPC running in the US East 2. Let me allow to open these VPCs. So one is the default VPC and another is the development VPC. I hope we have created this VPC somewhere. I will clean up this VPC for the sake of this lab. The VPC deletion is completed. We are getting the message as well that the three other resources are also being deleted with this VPC. Now we only have the one VPC in a region. So what I will do, I will search for the cloud formation and we are getting the cloud formation create and manage resources with the templates. I will open the cloud formation. You can create any resource with the help of the cloud formation. There's no specific requirement. If you have the template ready, you can use the cloud formation to create the resources. I will go to the create stack and I'm saying template is ready. There are other options as well. Use a sample template or create templates in designer. I'm not going to use these options. I'm going with the first option. Template is ready. Now over here we have the two options. Either we can upload the custom template or we can define the Amazon S3 URL for the template which is already being created by someone, either by the AWS or by some third party. So I'm going to use the existing template which is being provided by the AWS for the Kubernetes cluster VPC. And this is the template URL S3 US West 2 Amazon AWS.com Amazon EKS Cloud Formation 2010-19 AWS EKS VPC private subnets.eml. You can see once I will click outside this box, we are getting next enable. I will click on the next. Here we are getting the parameters which is already being filled. I am not going to change these parameters. I just provide the stack name and I am calling it EKS underscore VPC. This is the name of my stack which will create this VPC network. So VPC block is 192.168.0.0. Here we are getting the public subnet 01, public subnet 02, private subnet 01 and private subnet 02. Public subnet are using 192.168.64 and 192.168.0. The private subnet are using 192.168.128 and 192. You can see the CIDR block of all the private and public are the 18. Click on next and it is saying the stack name must contain the letters only, so I can't provide the underscore. I'm going to take it like level up EKS VPC. Click on next. It is asking for the key value pairs. Let's provide some key. I'm going to mention environment development. It is asking for the permission. Let's leave it as it is. Stack policy, leave it. Rollback configuration, I'm not going to roll back. Notification, stack operation, leave it as it is. Click on next. And here we are getting the complete configuration stack option, that this is the template we are using, the description of this template, this is this, these are the subnets, the public subnet and the private subnet and the VPC block which is being to use, this is the tag, and rest none of the configuration is being enabled. Let's click on the create stack and you will get a stack over here and it is saying create in progress. So we have to wait until this stack will be successful. If you will go to the stack info, here you will get the complete info, which is the stack ID, what is the status, creation time, deletion time, parent stack, success, description. In the events, you will get all the events. So you can see here we are getting the events like the VPC is being created, right? And the other resource are basically in progress. You can see the VPC subnet 2, subnet 1, route table 2, public subnet 1, public subnet 2. Lot of things are in the process. If we will go to the resources, here we will get all the resources which is being created and which are pending. Here we will get the output as defined as per the template. We will get the parameters which is being supplied as this template, and here we are getting the complete template. So this is the template we have supplied, right? If you want to go through this template, you can go through this template. So this is creating a lot of things, the subnets, private subnets, net gateways, internet gateways, a lot of things are over here. And in the output, it will supply the subnet IDs, security groups, and the VPC ID. Let's go to the chain set, and we don't have any chain set over here. The stack is still in progress. If we will go to the out resources, then most of the resources are being created and it is creating the net gateway 1 and net gateway 2. In the events, You can see a lot of resources are basically created and still are in progress. Let's refresh it. Net Gateway 2 and Net Gateway 1 in progress. Let's go to the resources and let's wait until both of the net gateways will be created. So team cloud formation is the another way. If you have the template ready for the AWS resources, you can use the cloud formation functionality. This is very rich to create the AWS resources, although you must supply the valid template. Or you can create the template as well, right? Because getting the template designer, you can design your own template and you can use it. Now let's refresh or reload your status. So most of the resources are done and we are getting the create template and we are getting a message that create complete. If we will go to the events, we will reload it, then the events are already done, right? Some events are still showing in the in progress, but that is the previous status. All resources are being created, and here if we will go to the output, we will get the output as well. This is the security group, these are the subnet IDs, and this is the VPC ID. So over here I'm showing the VPC ID which is ending with 616A7. Let's go to the VPC. Two VPC are present and we are getting the VPC level up EKS VPC which is ending with 6A7. So this is the VPC which is just created 192.168.0.0 block 16. So all the resources are being created. Now next we need to create the EKS cluster. So here we are on the machine, and to create the EKS cluster with the help of the CLI we need to execute few commands. So let's execute the create cluster command. So we will execute AWS EKS create cluster. We need to provide the cluster name hyphen hyphen name, then provide the cluster name. Suppose I'm providing level up hyphen EKS. Then we need to provide the region. So hyphen hyphen region equals to US East 2, right? Then we need to provide the role ARN. The role we have created yesterday, we need to provide the ARN of that role. So we will go to the AWS console. Please make sure you will provide the same region where you have created your VPC. In my case, I have created that VPC in US East 2, so I'm providing the US East 2. With the help of the cloud formation, if you have created the VPC in some other region, you need to provide that region. For the role ARN, we need to go to the AWS management console and we will go to the IAM. In the IAM, we need to go to the roles, and here we have created the AWS EKS role. I will copy this ARN and provide it on my terminal. Once the ARN will be done, we need to provide the security groups. So we will provide the resource VPC config subnet IDs, and to get the subnet ID, you again need to go to the AWS management console, and in the cloud formation, in the output, you are getting the subnet IDs. Here two subnets are for the public subnet and two subnet are the private subnet. I will copy all fours, go to the terminal and paste it here, right? After this, we will put comma and we will put another parameter security group IDs, and I will copy the security group from the output of the cloud template again. So here is the security group. I will copy this and provide it here. Hit enter. This will start the creation of your AWS cluster. You can see we are getting the JSON message that what is the configuration of the AWS EKS cluster. So this is going to be the name of your EKS cluster. This is going to be the ARN of your EKS cluster. The creation time is this. The version which is going to create is 1.18, which is the default version at a current date of the AWS EKS. The role ARN which is going to be used is this role which we have supplied. The resource configuration is this. These four subnets is going to be used, and this is the security group which is going to be used. This is the VPC which is going to be used, which is 6A7. You can see the same VPC we have created. Endpoint access true, endpoint private access false. Public access CIDR is 0.0.0.0 with the CIDR on 0. Kubernetes network config is 10.100 0.016 CIDR block, and the logging is false for API audit authenticator control manager and scheduler. Creating status is creating, certification authority null, platform version is EKS3, tags is null. Because we have not supplied any extra command as an argument, so these things are basically picked by default. If we will go to the AWS, if we will go to the EKS, Elastic Kubernetes Service, we will go to the clusters, then you can see level up EKS cluster is in the creating state, right? So this is the way how we can create the EKS cluster with the help of the terminal. I'm closing this video because EKS cluster can take more than 8 to 10 minutes, right? And in the coming lecture, I will show you how we can execute the application on the EKS cluster in the AWS. So thank you, team. See you in the next lecture. Hello, team. Welcome to Terraform training. And in the last lecture, we have seen how we can create the EKS cluster with the help of the AWS CLI. So we have left the cluster while it was creating. Now we will see if the cluster is ready or not. So we will go to the AWS and we will go to the AWS clusters. Here is my cluster and cluster status is active. We can also verify the same thing with the help of the terminal. So let's go to the terminal again. And here we will execute a command AWS EKS hyphen reason. Provide the reason where you have created a cluster. In my case, it is US East 2. Then provide the describe cluster command and the name of your EKS cluster, which is level up hyphen EKS in my case, and execute a query cluster.status. Right? So this is the complete command. Hit enter and you will get your cluster status is active. So my cluster level up hyphen EKS is active. Now we need to update the EKS cluster inside the kube cluster config. So we will execute a command AWS EKS hyphen reason, provide the reason which is US East 2, then provide a command update config hyphen name and provide the name of your cluster. In my case, this is the name of my cluster. Hit enter and this will update the configuration of your cluster into the kube config file on your machine. You can see here I'm getting a message ARN AWS EKS US East 2 164435 cluster syntax is added. If we will go to the AWS, we will go to the cluster, and if we will identify the ARN of my clusters, you can see this is the ARN of my cluster which is being printed on the terminal. If I will copy this and search on my browser, I will get the same value. So this ARN is basically updated in the kube config file. Now if we will execute a command kubectl get svc, it means get service. Once you will configure your cluster or you update the kube config, then only you will able to execute the command kubectl, right? Then only the kubectl commands will be executable on your cluster. Hit enter and you can see the Kubernetes cluster 10.100.0.1 is running port 443 TCP and age of running is 7 minutes 55 seconds. If we will again go to the cluster and we will go to the networking, you can see the service IP is 10.100.0.0 CIDR block 16. This is the service IP or the internal network IP of the Kubernetes. The same we are getting over here because dot 0 and 0 is basically used by the AWS. So dot 1 is assigned to the Kubernetes cluster. Now let's verify if any node is associated with this cluster or not. So we will execute another command kubectl get nodes. Hit enter and no resource found in default namespace. It means none of the node is connected with this Kubernetes cluster. So till now we have just set up the Kubernetes cluster. None of the node is basically associated with this cluster. So what I will do, if you want to cross check this information, you can go to the AWS console again. And on the AWS console, you can go to the overview. And over here inside the nodes, we are getting the 0th value. So now let's see if we want to create the nodes in the Kubernetes cluster, how we can create the nodes in the Kubernetes cluster. And for that, I'm again going to use the cloud formation. So I will go to the cloud formation and I'm going to create the another stack. I'm again use the ready template and I will use the AWS S3 bucket, but this time I will remove the VPC and I will add some template which will create the nodes. So here is the template file which will create the node, which is s3.usws2 AWS Amazon AWS.com Amazon EKS Cloud Formation 2010-19 AWS EKS node group.yaml. Click at outside, click on next. Here is the parameters. If you want, you can supply few parameters like the cluster name. So I will provide the AWS cluster name, level up hyphen EKS. Now I need to provide the cluster control plane security group. So over here we have the only cluster control security group which is EKS cluster SG, right? I will provide the security group. Node group name, suppose I'm going to provide the level up hyphen EKS hyphen nodes. The node auto scaling minimum 1, maximum or the desired capacity let's keep it 2, and max size also let's keep it 2. It is going to spin up T3 medium. So let's choose T2 micro if it is possible, and T2 small. Let's choose T2 small. I will don't touch it. The node volume is 20 GB. Key name I'm not going to define it. The disable empty state file is false. Now you can choose the VPC. I'm going to create the VPC, level up VPC, which I have created for the Kubernetes, and I will define the subnet. So suppose I'm going to define the private subnet. This is this, right? And I'm going to define the public subnets as well. So I have defined all 4 subnets. Click on next. Now it is asking for the tags, provide environment, which is development. Then I will leave other things as it is. Click on the next. Review your information which you have provided, and now check this checkbox and click on create stack. So this will spin up few nodes. So you can see the formation creation is in progress. We will go to the resources. No resource found. We have to wait. And if we will go to the events, then we are just getting a single event creation is in progress. Let's go to the services and open the EC2 instance in a new tab. Go to the running instances. No instance is in launch state. We have to go to the cloud formation again, and you can see AWS resource creation is initiated. We will go to the EC2 instance again and refresh it. No instance is still in the launch state. We will go to the If we will go to the event, then few events is basically completed and few is in the progress. So it is creating the instance profile. We have to wait until the instance profile will be created, and then it will launch the instance. In the resource, you can see few resources basically created. The security group is being created. The top node security group is being created, and instance profile is in progress. Node instance role is created. Security group node role group is created. So different resource as per this template is being created, and few resources are still in the progress. So we have to wait until the complete resources will be created, right? If we will go to the EC2 instance, we will refresh it. Let's refresh the status again, and we can see 2 instances are in the running state. The instance name I'm getting level up EKS nodes. This is the mix name which is created as the base of the template input definition. If we will refresh it, then we are getting the resource that node group is still in the progress, which is the auto scaling group, but rest of the things are basically done. If we will go to the outputs, then we are getting few outputs as well. Then this is the node instance role ARN. This is the auto scaling group name. This is the node security group which is being created, and over here we can see the template is completed. So the AWS cluster is basically created in the EKS cluster service, but whenever we are going to attach the worker nodes, these worker nodes will be the EC2 instances. So worker nodes will not be created in the AWS EKS service. Worker nodes will always be created in the EC2 instances, and you have the complete availability that which type of worker node you want to choose. What is the machine size you want to choose? What is the network you want to choose for the worker nodes? What is the security group? What is the VPC? What is the AMI? What is the key value pair? Everything you can customize in the worker nodes, right? So AWS Kubernetes service don't have any dependency for the user, so that the user will completely dependent on the Kubernetes cluster configuration. AWS Kubernetes cluster will only manage the master node, right? It will only manage the administration part, but rest all the functional part is the responsibility of the user, and user is solely responsible to create the configuration for the worker nodes. So we have created the worker nodes. We will go to the AWS terminal again, and on the terminal we will again execute kubectl get nodes, and you can see we are still getting that no resource found for the default namespace. It means the nodes which we just created is not still the part of the Kubernetes master node. So we need to attach these node with the master node, and to attach the worker nodes with the master node we need to do something. But the thing is not like that. Nodes are already attached as per the template we have defined, but we need to authenticate first, right? To access the configuration we need to authenticate first. So we will download some template YAML file, curl-o aws auth cm YAML. This is going to be the file name, and we'll download auth cm file from the AWS. Now once the file download will be done, we will open this file aws auth cm YAML, which we have downloaded, and here is the file. API version is v1, kind is config map. The name is AWS Authn. This is the namespace Cube System, and here we are getting the stub for the ARN. What I will do, I will go to the insert mode and I will try to replace this stub. So here we need to mention the node instance role, right? So we will go to the AWS Management Console, and in the AWS Management Console, we just created the stack formation level up nodes. Inside the output, you will get the instance node as a output value. I will copy this and paste it here. Save your file. To verify that the paste is done, we will open or view the file cat aws authn yaml, and you can see we are getting the URN over here. Now once this will done, we will set this inside the config map. So we will execute a command kubectl apply -f, then the file name. Once you will hit this command, you will get a message like this: config map AWS Authn unchanged or updated. In my case, I just configured it multiple times, so I'm getting it unchanged, right? Now clear out the console and execute a command get nodes again. So here is the command kubectl get nodes, and you can see we are getting the both of the nodes which we just created, right? The total age is 16 minutes. It means since last 16 minutes these nodes are running on this box. If you want to execute one more command -watch, you can watch these nodes as well. So you can see we are getting the nodes, and if other nodes will be added in this configuration or in this cluster, then these nodes will also be listed over here. So by this command -watch, the kubectl is continuously watching that how many nodes are basically being added inside the master node configuration. Put Ctrl C to exit out the command, clear out the console. Now we have created the master node, we have created the worker nodes. Suppose we want to install something on my Kubernetes cluster. And now suppose we want to execute the Nginx as a container on my Kubernetes cluster. So to create the deployment, I will execute a command kubectl create deployment -image equals to Nginx and the deployment name. Hit enter. And you can see this is saying deployment app Nginx is being created. If you want to see, you can execute a command kubectl get deployments, hit enter, and you will see a Nginx deployment is running. Now we directly cannot access the Nginx in Kubernetes on the deployment. So we need to create some service in the Kubernetes. So we will create a load balancer service in my Kubernetes cluster. So we will execute a command kubectl expose deployment Nginx app on port 80. The name of the service will be Nginx HTTP and type will be the load balancer. Hit enter. And you can see service is being created. If you will execute a command kubectl get services, so we'll get the service that Nginx service is running. Now what I will do, I will copy this URL, which is the external IP of your service, right? And I will wait for some time, at least wait for 90 to 120 seconds, because in AWS the DNS registration will take some time, and if you immediately copy this and hit it on the browser, then you may get the connection error. But after wait for 90 to 120 seconds, if you will copy this URL, basically this is the DNS record which is being created inside the Amazon. And on this DNS record, which is a service for the Kubernetes, you can access your Nginx deployment. So if I will copy it and go to the browser and paste it in the browser, you can see I'm getting the Nginx page. So by default, this service which is being created by the Kubernetes, that is being redirected to the deployment which we just created. So this is the way how we can set up the Kubernetes, how we can set up the worker nodes, and how we can execute the application on the Kubernetes. Now team, the nodes which we have executed in this lab, they all are the heavy nodes. So AWS must put some charge on these nodes. So what we will do, before closing this lab, we will delete these nodes. So I will go to the AWS Management Console again. Now to delete the resources, what you need to do, you just need to click the cloud formation and click on the delete. You will get a message as well, deleting this stack will delete all the stack resources. I will click the delete stack button. Over here you are getting a message. Let's close this message and refresh your stack status. You can see the stack is in deletion. If we will go to the EC2 instance, we will refresh the instance status. We are also getting that these are also in the shutting down state. Same thing we will do with the another CloudFormation stack which we created for the VPC network. And what I will do, I will delete the EKS cluster explicitly, right? So I will click on the delete and provide the level up hyphen EKS, which is the cluster name. Click on delete. So this is the way how we can set up the AWS EKS worker nodes and the deployment or the application inside the Kubernetes. So I hope team the lab was quite helpful for you. Thank you team. See you in the next lecture. Hello team, welcome to Terraform training. And today we will see how we can create the EKS cluster using the Terraform configuration. So first we will try to understand the Terraform configuration for the EKS cluster, and then we will see how we can deploy the EKS cluster with the help of the Terraform. So first let's go to the code editor and let's understand the Terraform configuration for the EKS. So team, here we are on the code editor and I have created a new directory case study EKS. In this case study EKS, I have created a few files which have the configuration of the Terraform which will create the EKS cluster on AWS. So let's try to understand one by one. First, let's try to understand the VPC, because whenever we are going to create the EKS using the Terraform, we are going to create altogether a new VPC. So over here, I'm using the module VPC and I'm using the registry.terraform.io module, Terraform AWS module VPC AWS. The version I'm using, which is 2.64. If you want to go with the upgraded version, you can go to the registry.terraform.io and you can search for the module VPC and you will get the version itself. Let me show you. So if you will go to registry.terraform.io and we will search for the VPC, go to the modules and you will get the Terraform AWS module VPC. Click it and you can see over here you are getting the version. Right now the latest version is 2.64. In the meantime, whenever you are going to execute this lab, if you are getting the latest version, you can use the latest version as well. I'm defining the name of my VPC will be VPC-module-demo. This is the CIDR block range which will be assigned to my VPC. The availability zone I'm taking from the data source. Data source AWS availability zone, available names 0 to 2, it means 0, 1, 2. So whatever the region I'm going to choose, that region must have the three availability zones. The private subnet will be 0, 1, 2 and 3, and the public subnet will be 101, 102, 103. So total 6 subnet is going to be created in this particular VPC. Net gateway false, VPN gateway false, and this is the tag where dot cluster name hyphen VPC. This cluster name I'm getting inside the variables. So let's go to the variables. I'm just using the two variables. First is the cluster name and second is the AWS region. By default, here I'm taking the AWS region EU West 1, which is Ireland region. Let's go to the provider. Inside the provider, I'm using the provider AWS. The reason I'm reading from the variables. AWS region is current. The data provider for the AWS region will use the current region. The data provider for the AWS availability zone will choose the available availability zones. Then we have the IAM.tf and we have the EKS cluster.tf. First, let's try to understand the IAM.tf. So here is the IAM.tf and very first resource I'm creating the IAM role. I'm creating a role EKS underscore cluster. It means this role will be created for the EKS cluster. The name of the role will be EKS hyphen cluster and I'm assigning a policy to this role. So policy will be defined like this. I'm using a policy version which is standard in AWS. The effect of the policy, the service which is going to be used eks.amazonaws.com. You can go to the policy and you will get the exact JSON from the Amazon AWS documentation. Action will be assume role, right? So over here I've created the EKS cluster role for the EKS cluster. Then I'm basically binding few policy with this role. First, I'm binding the AWS IAM role policy attachment. It means I'm binding this particular policy with this role. So over here, I just created the role with this policy, but I need few more policies as well to assign the EKS cluster so that we will be able to create the EKS cluster. So first policy I'm defining is the Amazon EKS cluster policy. First is the Amazon EKS cluster policy, which I'm binding with the EKS cluster using the policy ARN. The second policy I'm binding is the Amazon EKS service policy. So these are two policies which I'm binding with this role which we have created. The same policy we have used whenever we was created the role manually in the earlier labs. Then I'm creating another role, AWS IAM role, EKS node. It means this role we are creating for the nodes. In the earlier lab, we have created the role with the help of the cloud formation. But here I'm creating the role with the help of the Terraform. The name of the role will be EKS node group level up. This is the policy. By default, I am attaching this role, which is simply EC2 AWS Amazon.com policy assume role. Earlier, I have chosen the EKS Amazon AWS.com policy. Now again, I'm attaching few policies to this role, to the new role, which is EKS nodes. First policy I'm assigning Amazon EKS worker node policy, because this role will be used by the EKS worker nodes. So we need to attach the policy with this role, which will help us to attach the worker nodes with the EKS cluster and create the communication between the workers and the EKS cluster. So first is the Amazon EKS worker node policy. Second, I'm using Amazon EKS CNI policy. And third, I'm using Amazon EC2 container registry read only policy, which will help us to read the container files. So this is the complete IAM. I have created two roles, first for the EKS cluster and second for the EKS nodes or the worker nodes. Two policy has been assigned to the EKS cluster and three policy has been assigned to the EKS node. Now this is the last configuration file, which is EKS cluster.tf, and over here I will create my EKS cluster. The resource which I will use is the AWS underscore EKS underscore cluster. The name of the resource will be AWS underscore EKS, and this is the name of your EKS cluster. Here I'm choosing the role ARN, and you can see I'm choosing the role ARN EKS underscore cluster, the first role I have created in my IAM.tf file. Inside the VPC config, I'm getting the subnet, so I'm only getting the public subnets. Inside the VPC module, here I have defined the public subnet, which is 101, 102, and 103. So I'm choosing the public subnet for the VPC config. Now I'm saying depends on, and here I'm attaching few policies. Amazon EKS cluster policy, Amazon EKS service policy. If you remember, same policy are being attached to this role, cluster policy and the service policy. Then what is the need? Why we are defining these policies over here in the depends on? It means don't start the creation of the EKS cluster until unless these policy will be attached to the node. So whenever Terraform will start creation of the resource, first it will create the resource which have these policies, and only after then it will start the creation of the EKS cluster, because EKS cluster need these policies as a role which is going to assign to the EKS cluster. The second resource I'm defining is the AWS EKS node group. Over here, I'm not defining the node itself. I am defining the node group. And this node group have some configuration, right? If you are defining the all configuration, then that is good. If you are defining only very few basic configuration, then that will work as well. And rest of the configuration will be picked by the EKS node itself, right? So I am defining, so over here in the above resource, I have defined the cluster, but here I am defining the worker nodes for the EKS. First, I am defining the cluster name, to which cluster this worker node is going to be attached, right? So I'm defining my cluster name, which is AWS EKS cluster, which is this AWS EKS and the name. Then I'm defining the group name, the node group name of this group, which is node underscore level up. Then I'm defining the node role. So I'm defining the node role which I've created over here, the second role, this, right? Because this is the role which we have created for the nodes. So I'm defining the node role over here, and then we are defining the subnet IDs. So again, I'm defining the public subnets. Here I'm defining the scaling capacity. The desired size is 1, max size is 1, and min size is 1. You can play around these sizes, right? You can keep the desired size to max size 4, min size 1, or you can keep the same configuration which I have taken 111. I will explain the reason why I am taking 111. Then we have the depends on, and the depends on I'm defining three policies: Amazon EKS worker node policy, Amazon EKS CNI policy, Amazon EC2 container registry read only policy. These are the same policies which I have assigned to the node role, right? See, CNI EC2 container registry. Now, the question is why I'm defining 111. So team, please make sure whenever you are going to use this configuration on the Terraform, it will create the EKS cluster which will charge you 20 cent per hour. Plus it will also create a T3 type of machine, T3 small machine or T3 medium machine. As I remember, it is a T3 small machine. So that I'm just using the one node, so that only one T3 dot small machine will be launched. because T3 dot small machine is also a chargeable machine, right? That is not a free machine. So please make sure if you are willing to spend few cents, then that is fine, right? You can practice this lab. Otherwise, you can just go through this lecture and you can see how we are creating the EKS cluster and the nodes with the help of the Terraform. So thank you, team. In the coming lecture, we will see how we can deploy the Terraform and nodes with the help of the Terraform configuration. Thank you, team. See you in the next lecture. Hello team, welcome to Terraform training, and today we will see how we can deploy the EKS cluster with the help of the Terraform configuration which we have created in the earlier lecture. So let's go to the machine where we are executing the Terraform. So here is the configuration which we have created, and we have four files: EKS cluster TF, im.tf, provider.tf, variable.tf, and the vpc.tf. Whenever I will execute the Terraform apply, first it will create the VPC, then it will create the associate roles, and then it will start creating the EKS cluster, because in the EKS cluster we have mentioned the dependency. Once the EKS cluster will be defined or it will be created, it will start creating the worker nodes. So let's go to the machine where we are executing the Terraform, and let's try to create the EKS cluster on AWS with the help of the Terraform. So we have logged in the Terraform machine and we are present inside the directory Terraform. We will execute pwd. You can see we are inside the Terraform. Let's put ls over here, and I have already executed the git pull so that I'm getting the case study EKS2 over here. Let's go to this directory case study EKS2, put ls, and we have all the files: EKS cluster, im.tf, provider.tf, variable.tf, and vpc.tf. I have the tf state and backup state as well, because before recording this section I have executed the same. So let me remove these. Now we just have the files which we have created. Over here, if we will get the variable.tf, then you can see we are executing this Kubernetes cluster in the EU West 1, which is Ireland region. Let's apply the Terraform. So execute Terraform plan to verify that how many resources we are going to create. So total 28 resources will be created as a part of this lecture. Let's see what are those resources. So the list of the resources have the EKS cluster itself. Then it will create the node group with this setting which we are creating. Then it will create the IAM role for EKS, role for nodes, attachment policies. Total 5 attachment policies we have defined inside our IAM roles. It will create the internet gateway, which will be created with the help of the module we have used, the VPC module, public internet gateway, private routing tables, private table 1, private table 2. In the same way, it will create 3 public tables, right? Then it is creating the association, see all these association tables. Then it is creating the subnet, the private subnet and private subnet 1. 3 private subnet it will be created and 3 public subnet it will be created. Then it will create the VPC itself. I'm going to execute it. Terraform apply. It is refreshing the state, and we need to put yes. So it will start creating the resources. And you can see it has started creating the resources: the VPC, EKS cluster, EKS policies, subnets, right? Association tables. Now it is creating the internet gateway. So if you want to see the progress, you can go to the AWS console. So we are in the AWS console and we are in the region EU West 1 where we are creating the resources. Let's open few configuration. Let's open few services. I will open the IAM, VPC, Kubernetes, and EC2. First, let's go to the IAM, and in the IAM, if we will go to the roles, then you can see EKS cluster and EKS node group level up. These are the two nodes. These are the two roles which we have created. If we will go to the VPC, we are getting two VPC, and level up TF EKS demo VPC. This is our VPC, right? This is the VPC which we are creating. In the same way, we will get the 6 subnets which we are creating. See, these are the 6 subnets which we are creating over here. If we will go to the EKS, we will go to the clusters. Then our cluster EKS cluster level up is in the creating state. This may take some time. This may take up to 10 to 14 minutes. So if you are getting this kind of a status on your console, like creating, you have to wait. So it is creating the EKS cluster since last 2.5 minutes, but it may take more than 13 to 15 minutes. So you have to keep some patience. The EKS cluster creation will take some time. We will wait for the 15 minutes from here, and after 15 minutes you can see the EKS cluster will be ready and Terraform will start creation of the node group. So it's already 13 minutes and the cluster is still creating. So let's go to the AWS console and let's see if the cluster is ready or it's still in progress. So I will refresh the status and the cluster creation is still in progress. So we have to wait until the cluster will be ready until we can go through the configuration. It is using the 1.18 Kubernetes version. The platform is EKS.3. We don't have any compute engine associated with this cluster till yet. In the networking, you can see it is using the network which we have created with the CIDR range 172.20.0.0 CIDR block 16. Here few public subnet which this cluster is using. If you want to go through any public subnet, you simply click it and you will see this is the public subnet which is the part of our custom VPC. See, this is the subnet of our level up TF EKS demo and this is the public subnet. And if we will go to the add-ons, we don't have any add-ons inside the logging. The API server, control manager, audit, scheduler, and authenticator are disabled. These are disabled by default because we have not explicitly enabled the logging in our configuration, so that it is not being enabled over here as well. In the update history, we have not updated the cluster. Inside the tags, we are getting the tag EKS cluster level up. Let's refresh the status again and it is active. If we will go to the compute, then you can see here it is creating the node level group and status is in the creating state. If we will go to the Terraform, then you can see EKS cluster is still creating, that is created. Now it is creating the node group. If you will go to the ECS, go to the running instances, you can see none of the running instances present over here. But soon with the help of this node group, a single instance will be added over here which will be t3.small. And you can see a node is being added over here which is t3.medium, right? So by default t3.medium is a node associated with the Kubernetes worker nodes. This node have some configuration. So if we will go to the node configuration, I will pull it up. Here's the description, which is the node, the instance IDs, the finder, the VPC ID, which is level up TF EKS demo VPC, which is our custom VPC. Here's the public IP. This is in the EU West 1A. The security groups associated with this. The AMI ID is this Amazon EKS node 1.18. Please make sure the AMI of the journal EC2 instance and AMI of the AWS Kubernetes EC2 instance are the different. The subnet ID is this. This is the network. This is the IAM role which is using, which we have created EKS node group level up. And the number of CPUs are 2. If we will go to the status check, here is no status in the monitoring and tags. Right. So by default, these tags are basically added with this node. AWS auto scaling group name, EC2 feat ID, launch template version, cluster name, level up EKS, node group name, owned by EKS cluster, autoscaler, K8IO, autoscaler enabled and on by the EKS cluster level up. If we will go to the EKS, refresh it here, you can see one node is live. Now go to the Terraform. You can see here the complete creation is done. Let's clear out the console, and if you want to spin up few application on it, we will spin up the application as well. So let's execute the command kubectl get nodes, and we are not getting any node, right? We are getting the error. So what we need to do to connect with the kubectl, we need to update the kubeconfig. So I will update the kubeconfig by AWS EKS -- region EU West 1 update kubeconfig -- name, and here we need to provide the cluster name. So my cluster name is EKS cluster level up. Hit enter. Now we are getting the message that updated the context of the kubeconfig. Let's execute the command again, kubectl get nodes, and we are getting the node ready, right? This is my node. Now if we want to execute some application, we need to execute few commands. So let's try to execute the nginx on this cluster. I will execute a command kubectl create deployment -- image equals to nginx and the deployment name, which is nginx -app. Hit enter. Execute the command kubectl get deployment, and we are getting the command output nginx app. The ready is 1. If you are getting 0 over here, it means you have to wait for some time. The deployment is still in the creation. Please make sure The deployment will only accessible once we are getting 1 over here, it means the availability of your deployment, and 1 over here it means the number of deployment you are executing with this name. Up to date is 1, available is 1, age is 24 second. If you will execute the same command again, you can see the age is. Now let's expose this nginx to some load balancer. So I will execute a command kubectl expose deployment. I will provide my deployment name, then I will provide the port on which port I can access my deployment, provide the service name on which service I want to expose this deployment, and the type of service, which is a load balancer. What this will do, this will create a load balancer in the AWS. If you want to see, let's execute kubectl get services, hit enter, and here you can see we are getting the service nginx http. If you want to describe this service, you need to execute a command kubectl describe svc, then your service name, and you will get the complete description of your service, that the service name space is default, the name of the service is nginx-http, which app or which deployment this service is attached, the selector of this app, the type of the service, the IP of the service, and the ingress load balancer DNS of your service. The target port is 80, and this is the port of the Kubernetes service, right? And here we are getting the ensuring load balancer reasons, the events which happen in the load balancer. If you go to your AWS console, you will get this load balancer in your load balancer as well. So go to the EC2 instance and go to the load balancers, and you can see the same load balancer is listed over here. And this is the DNS of your load balancer, which is AC460409. AC460409. If you will copy this load balancer, go to your browser again and hit this load balancer. This will resolve your nginx service. See, we are getting the default page of the nginx, the deployment which is running inside the Kubernetes. If you are not getting this page, you have to wait for some time, because sometimes the fresh DNS on the AWS may take some time. It may take 19 to 180 seconds. So if you're not getting this page, you have to wait for some time. And after a DNS registration, definitely your load balancer should resolve your application. So this is the way how we can create the EKS and the worker nodes and the roles with the help of the Terraform. Let's go to your machine, the Terraform machine, and execute Terraform destroy. So once you will execute the Terraform destroy, it will ask for your confirmation, provide your confirmation, and it will terminate all 28 resources which is created as a part of this lab. So this will start the destroying of the resources. So thank you team. In the coming lecture, we will see some more use cases. Thank you. Thanks for your time. Hello team. Welcome to Terraform training. And in this section, we will learn about the ELK. So in AWS, ELK service help us to debug the logs and get the relevant data from the logs. So we will learn about the ELK basics. We will learn about the application of the ELK, and then we will see how we can deploy the ELK in AWS. So first, we will try to understand what is the ELK and what is application of the ELK. So till now we have seen how we can create the networks, how we can create the EC2 instances, and how we can execute some applications of the instances. But after execution of your application, the question is, how can you debug your application in production? If there are 100 of the servers are running in the production, how can you debug that which server is basically throwing the issue and which server is slow in performance? So production issue debugging is the biggest challenge for the companies who have the big server farms in the production. ELK is the solution for such problem. ELK stands for the Elasticsearch, Logstash, and Kibana. So ELK is the combination of the Elasticsearch, Logstash, and Kibana, and these services are the AWS services. So we will execute the Elasticsearch, Logstash, and Kibana to make a perfect application. With the help of that application, we can retrieve the logs which we want, and we can debug the issue on the basis of the logs. Each of these tools which are the part of the ELK, these are the open source tool and can be used independently. It means Elasticsearch can be deployed independently, Logstash can also be deployed independently, and Kibana can also be deployed independently. There's no restrictions. Then you need to deploy all these product on the AWS. You can deploy these products or these tools on GCP as well, on Microsoft Azure as well, or on your on-prem machine as well. So there's no restrictions that the tools are only executable on the AWS.
Each of the tool is open source technology and can be used independently on any other machine as well. But together, the Elasticsearch, Logstash, and Kibana provide a solution to the common problem: the efficiency storage, search, and visualization large log files or the logs. So, with the help of the Kibana, Logstash, and Elasticsearch, you can create a perfect dashboard. You can create the inventory of the logs, and you can efficiently store your logs. Let's discuss about each of the components separately. First, let's discuss about the Elasticsearch. Elasticsearch is the central component of the ELK stack, and Elasticsearch offers multi-node scalable distributed search and analytic engine. So whenever we are putting the logs in the storage, if we want to analyze the log, we want to query on the log, then Elasticsearch is the tool which will help us to search the logs across the distributed multi-zone scalable nodes. Elasticsearch store and indexes data centrally and provide the REST API access to it. It can be taken as a database for the text file. Including the search and the analytic power, Elasticsearch also provides the indexing and the storage for the log files. And we can access the files with the help of the REST API and the Elasticsearch. The another tool is the Logstash, and Logstash is the input for the Elasticsearch. It means Logstash can receive logs or text from the different source, transform it, and send it to Elasticsearch. So Elasticsearch is something which will work on the data, which will store the data. But who will send the data, right? Who will provide the data to the Elasticsearch? So Logstash will basically get the data from the nodes and it will supply the data to the Elasticsearch. Then we have the Kibana, and Kibana gives us a UI to the Elasticsearch using which you can visualize and navigate to the data storage in the Elasticsearch. So the complete structure will be like this. This is the complete component which is called ELK, right? And in the ELK we have the different components. So here is the first component which is the Logstash. Here we have the second component which is called Elasticsearch, and here we keep the third component which is called Kibana. So this is the Logstash, this is the Elasticsearch, and this is the Kibana. Logstash will basically retrieve the data from node. It will get the data from node and then it will supply that data to the Elasticsearch. So the data which we are getting from here, this will be supplied to the Elasticsearch. Elasticsearch will store that data, plus that will put indexing, and then we have the Kibana. Kibana will basically communicate with the Elasticsearch, right? And what is this? This is the UI for visual effects. So on Kibana, you can visualize your data, and this is the complete ELK. In the Kibana, we can create the index, right? And these index will work on the Elasticsearch. With the help of the Kibana, we can create the dashboard and we can analyze the logs. So this is the complete structure of the ELK. So I hope we are pretty much clear about the components of the ELK. In the coming lecture, we will deploy the ELK cluster and we will see how we can access the ELK cluster and how we can access the logs on the Kibana. So thank you team. See you in the next lecture. Hello team. Welcome to Terraform training. And today we will see how we can deploy the ELK in AWS. First, we will deploy the machines and we will install the ELK manually on that machine. And in the coming lecture, we will deploy the complete ELK application with the help of the Terraform. Why we are going to execute the ELK manually in this lab? Because we need to understand that what are the components which we require to install the ELK on AWS, so that it will help us in the coming lecture to understand the Terraform configuration. So let's start with. So I am on my code editor and here I have created a new directory case study ELK, and inside the case study ELK I have created another directory demo1. Here I have created two files, create instance.tf and variable.tf. I will use these files to create the instance on the AWS. Over here you can see we have few variables like AWS region. I'm taking AP South 1 provider, which is AWS, and the reason is AP South 1. Here I'm taking the map of the AMIs, right? The AMI for US East 1, US East 2, US West 2, West 1 and AP South 1. and I'm taking the path to my public key. At this location, I have created my public key. We are using the same public key which we are using in this lab. Then we have the create.instance, and here what I'm creating. First, I'm creating the AWS key pair, right? And I'm reading the variable which I've declared inside the variable.tf. Then I'm creating the AWS security group. I will name it allow underscore elk. Here you can see I'm putting few ingress. First, I'm putting the ingress from port 9200 to port 9200 and TCP protocol for the CIDR blocks 0.0.0.0, CIDR range 0. This port is open for the Elasticsearch. Elasticsearch application will execute and accessible on port 9200. Then I have opened another port 5043 to port 5044. This is again a TCP protocol, and CIDR block will be 0.0.0.0, CIDR range 0. This ingress I'm creating for the log stash. So once log stash will execute, it will read the traffic from port 5043 and send the traffic to 5044. Then I'm opening another ingress which is 5601 TCP protocol with the side range 000, right? This port will be accessible, or this port is open for the Kibana. Then I have the another port ingress which is 22. This is for the SSH connection, and in the egress I'm taking from port 0 to port 0 protocol -1 for the all IPs. After this, we are creating the AWS instance. The name of my AWS instance will be my first instance. AMI value I'm reading with the help of the lookup functions from the variable. And here you can see I'm taking instance type m4.large. Why I'm taking m4.large? Because log stash need a lot of memory to execute, right? M4.large machine will have the 2-core CPU plus 8 GB RAM. So if you are going to execute this lab with T2.micro or T2.small, right? This lab will not be executable, and you may face the error in the installation of the log stash. I'm taking m4.large, and it is recommended to take this machine. Availability zone, I'm taking AP South 1A. Key name, I'm reading from the above resource which I have defined. Security group, I'm defining the AWS security group and reading the security group ID which I have defined over here. Depends on the security group. So once the security group will be created, then the instance creation will be execute. In the resource, I'm attaching a AWS EIP, Elastic IP, and I'm attaching this EIP with my instance. This EIP will help us to access the machine on internet, and then I have the output of the public IP, so I'm printing the public IP. This is the configuration which I have prepared for this lab. Right now we will go to the machine where we are executing the Terraform. So we are on the machine where we are executing the Terraform, and we are inside the directory Terraform. I will execute git pull, but I have already get the git pull, so I will get already updated. Right now we will go to the directory case study elk demo1, and here I will execute the Terraform init. Terraform is initialized. I will execute the Terraform plan. You can see 4 resources need to be added. What are those 4 resources? So first is EIP, then your AWS instance, then AWS key pair, and AWS security group. These are the resources which would be created. I will execute Terraform apply. So it is creating the instance. We will log into the AWS account. So I have logged in my AWS account, and I'm inside the AP South 1, Asia Pacific Mumbai. Here I will go to the EC2 instance, and we can see we are getting one running instance and one Elastic IP. We will open the EC2 instance. The instance is running, status is initializing. This is m4.large machine, right? You can see this is the name custom instance. So this is my instance, and here we are getting the Elastic IP 6513145. I will copy this public IP, go to the machine where we are executing the Terraform, and clear out the console. Now I will SSH my machine. So I will provide a command SSH my IP -l ubuntu -i, then my public key. Hit enter. Provide your confirmation, and you are inside your machine, right? You are inside your AWS machine. Let's switch to the root user sudo -su, and we have switched to the root user. Now, to install all these 3 tools, we need to execute a set of commands. So we will execute the set of commands one by one, and in the coming lecture, I will post these commands so that you can also follow these commands. So first, we will update the package manager. I will execute sudo apt-get update. Package manager update is done. Now we will upgrade the packages which are present in the package manager. So I will execute a command sudo apt-get upgrade -y. This will upgrade the packages which are required to upgrade, and it's done. Clear out the console. Now to get the better view on the console, I will execute a tool called Fish, right? This tool is not required, that is not the part of the Kibana Elasticsearch or the Logstash. I'm just downloading this tool to get the better view on my console. So we'll execute a command sudo install fish-y. This will install the fish. It will take some time, we will wait. And this is done. I will clear out the console and type fish. Hit enter and see. We are getting the proper color coding. Clear out the console. Now we will start execution of the ELK. And very first we will install the Java because Logstash requires Java to execute on your machine. We will execute a command sudo apt-get install default -gre-y. Hit enter. This will install Java on your machine, and you can see we are getting a message done. Let's clear out the console and verify the Java version. So Java-version, and we are getting OpenJDK version 1.8.0_275 is installed on my machine. After this, we will install the Elasticsearch. To install the Elasticsearch, first we will add the key of the Elasticsearch. Then we will add the Elasticsearch package in the init source D package. Elasticsearch also requires the Apache, so we will also add the Apache over here. So we will add the Apache apt as well. Once we will create the source list, we will update the package manager again, right? And now we will execute a command to sudo apt-get install Elasticsearch. This will start the installation of the Elasticsearch. So you can see total 535 megabyte of the data needs to be downloaded. That is the size of Elasticsearch. So we have to wait until the complete Elasticsearch will be downloaded and it will install on my box. You can see the Elasticsearch is downloaded. I will clear out the console. But before start the Elasticsearch, I need to modify some YAML file. So I will modify the Elasticsearch YAML file which is present at the etc Elasticsearch. I will open it, and over here I need to go to the networking section. Here is the network section, and inside the network section you can see we are getting the network host and the network port. So for the Elasticsearch, I will update this network host, and suppose this time I want to execute the Elasticsearch on my box where I'm executing this command. So I will put the local host. I want to execute the Elasticsearch on port 9200. So I will just uncomment this line. I will save this. Once you will save this, we will start the Elasticsearch service by command sudo service elasticsearch start. Hit enter. This will take some time and it will start your Elasticsearch service. Once the command will exit, if you want to check the status, you can execute the command sudo service elasticsearch status. Hit enter, and you can see my service is in the running state. Put Control C. If you want to verify that, you can execute a command like curl or sudo curl http localhost port 9200. Hit enter, and we will get a output like this. Cluster name Elasticsearch, cluster UID, this is the unique UID, version 7.10.1 is installed on my box, license version 7.8.7.0. Once the Elasticsearch will be done, I will clear out the console. Elasticsearch is completed. Now we will install the Logstash. To install the Logstash, we just need to execute a command sudo apt-get install Logstash. That's it. Hit enter, and this will download the Logstash and it will install the Logstash. Please make sure, as I told you, if your machine is not a M4 large machine, or the size or the RAM of your machine is less than 8 GB, it may possible that Logstash installation will fail on your machine. So please make sure we are executing this lab on at least 8 GB RAM machine. I'm executing this lab on M4 large. Logstash is also downloaded and installed. For now, we are not starting the Logstash, we are just installing the Logstash. Before starting the Logstash, I will install the Kibana. To install the Kibana, I will execute a command sudo apt-get installed Kibana. Hit enter. This will download the Kibana, which is in size 693 megabyte, and it will install the Kibana. It is unpacking the Kibana 7.10.1. It will take few seconds to install. We have to wait, and installation is done. Now before starting the Kibana, we need to modify the configuration. So you will get a file inside the etc. The file will be kibana.yaml. So I will edit this file, and over here first I will edit the server port. So I will uncomment this. Then inside the server host, you can see we are getting the local host. I will uncomment this, and instead of the local host, I will provide the IP over here. Suppose I want to access it from anywhere, so I will execute 0.0.0.0. We will move a bit, and we will get a entry like elasticsearch.hosts. I will uncomment this. This URL will provide the host of the Elasticsearch. So my Elasticsearch is running on the same machine, and it is executing on the local host port 9200. So I'm providing a single entry like this. If you have a multiple Elasticsearch machines, right, and you want to execute the multiple Elasticsearch machine with the single Kibana dashboard, you can put comma separated entries over here. This is a list. I will save this file, clear out the console, and start the Kibana. Sudo service Kibana start, hit enter. Kibana is started. If you want to verify, you can execute a command status and see Kibana service is in the running mode. So as Kibana is executing on port 5601, what I will do, I will go to the browser. I will copy the elastic IP of my box, paste in the browser, and try to access application on 5601. Hit enter and see. We are getting the Elasticsearch homepage, right? It is saying loading the Elasticsearch. Right now, I'm not going to execute any operation over here. I will leave it as it is, and I will go back to the terminal. Now there is a one more software called Beats. Beats will basically collect the data, and it will provide the data to the Logstash to process the aggregation. So what Beats will done? Beats will basically collect the data from the multiple threads, and it will supply the data to the Logstash. By this way, Logstash will work efficiently. It will aggregate the data and supply the data further to the EC2 instance. So we will install the Beats as well. To install the Beats, I will execute a command sudo apt-get install metric beat. So now we have the two log gathering services. One is the metric beat and another is the Logstash. Let's clear out the console again. And to work with the Logstash, we need to configure the index in the Logstash. Whatever the log you want to access in the Logstash, or you want to capture with the help of the Logstash, you need to define these logs inside the config file. So I will open a Logstash file called apache01.conf, which is present inside the conf.d of the Logstash. Hit enter, and here I will provide some data. So I'm providing a JSON over here. You can see this is the input file, path of the logs, which is apache daily access.log. It means I'm creating this file to access the log of my Apache server. Starting position beginning, since part db dev null, filter grok match message, combined patch logs. This is the timestamp. It means log will start with the timestamp. GeoIP is the client IP and Elasticsearch IP is the, and what is the Elasticsearch IP, which is the localhost 9200. And again over here you can see this is the list. So if you have the multiple servers where you are executing the Elasticsearch agent, you can mention the multiple entries over here. I will save this. Now I will start the Logstash. Hit enter. You can see the Logstash service is also exited. If you want to verify the status, you can execute the command logstash status, and you can see the Logstash is also running. Put Control C, clear out the console. So we have executed the four services. Let's execute one more thing. ps-ef grep java. We want to verify that how many Java processes are running on my box. Hit enter. So few Java processes are running on my box, and the first is the Elasticsearch itself. What is the second process? And second process is the Logstash process. So to execute the Elasticsearch, also to execute the Logstash, you need Java on your box. That is the mandatory thing. Now I will go to the dashboard, and I will clear out the console. I will also exit from this terminal from my Amazon machine because I don't want to access this Amazon machine again. Right here, I am present on my machine where I am executing the Terraform. I will clear out the console and we will go to the browser where we have opened the Kibana. In the Kibana, it is saying add data or explore my own. I will go with the explore my own. We are getting a home page like this: enterprise search, observability, security, Kibana, visualize and analyze. I will go with the Kibana visualize and analyze. Now I'm getting the UI something like that. If you will go to the menu bar, over here you are getting the Kibana dashboard, overview, discovery, dashboard, canvas, maps, machine learning, and the visualize. Let's open the discovery. It is asking to create the index pattern, right? If we will go to the dashboard, we don't have any dashboard, so we need to create the index pattern first to create the dashboard. Let's go to the management of the Kibana and management, and inside the management we are getting the stack monitoring and stack management. Let's go to the stack management. Over here we are getting the data and we are getting the index management. Let's go to the index management and you can see we are getting a default index called logstash. We are not getting the metric beats index over here. Ideally we should get that index. So we will go to the terminal again, log into the sudo users, and seems we forgot to start the last metric beat service. So let's find out the status of metric beat service. And yes, we have not started it. Let's start this service as well. Find out the status again, and metric beats is also running. Let's put control C, go to the browser, go to the Elasticsearch and refresh it. We will get one more index over here for the metric beats. We are getting the metric beats index as well. And over here we are getting the storage size as well. Log stash size is just 208 kilobyte. Why we are getting 208 byte? Because we have not executed anything inside my Apache server. So no log is being created inside the Apache server, but metric beat is basically getting the system logs. So we are getting the data which is increasing in the metric beats. Let's see how we can create the dashboard or the discovery. So we will go to the discovery, we'll go to the create index pattern, and here we need to mention the index name. So as you can see, we have only two index, the log stash index and the metric beat index. I will copy this metric beats and I will go to the index management. I will put it here, hyphen asterisk, which is creating the both alias and the index. Next step, time field. I am getting with the timestamp and I will click on the create index. That's it. Now I will go to the discovery again. Let's wait. You can see discovery is applying the filter, and over here we are getting the data of my system. So these are the logs which is being created by the metric beats on my box, right? And we are getting the logs since last 5 minutes. So team, this is the way how we can create the centralized logging system in the AWS, right? You can see if you will expand this, you will get the complete logs. We are getting the view surrounding and view single document. Let's click on the view single document. So this is the complete log which is being created. The process argument, process logs, memory consumption, everything is basically being logged with the help of the metric beats. With the help of the log stash, you can simply identify the log which is specific to some process. Right, I have configured the log stash for the Apache, but I'm not executing the Apache, so that I'm not getting the logs as well. Let's go to the terminal again. Exit from your terminal, exit from your Amazon box. We are on the Terraform machine. I will clear out the console and I will execute Terraform destroy. Hit enter. This will destroy the Terraform machine or the resources which we have created as a part of this lab, right? So team, we have seen how we can create the instance and what is the configuration of the instance we need. Then we have installed the Elasticsearch, Logstash, Beats, and Kibana. In the coming lab, I will show you how we can execute and install all these things with the help of the Terraform and user data. So thank you team. See you in the next lecture. Hello team, welcome to Terraform training, and today we will see how we can deploy ELK using Terraform. In last lab, we have executed the Terraform file to spin up the EC2 instance, and then we have executed few commands to install the ELK on the EC2 instance. Today we will see how we can do all that stuff with the help of the Terraform. So we have already seen how we can spin up the instance, but the question is how we will execute the command on EC2 instance. If you remember the previous lectures of this course, then we have executed all that stuff. We just need to revise the concepts which we have learned and we will do it. So I have created few files. Let's go through these code files and we will see how we can execute the ELK on AWS with the help of the Terraform. So team, we was working on the case study ELK, and in the last lab we have seen the demo one. Today I have created another directory called demo2, and here we have few files. So we have the apache 01.conf. This is the conf file which we have used in the last lab. We have the elasticsearch.yaml. This is the file which we have updated in the last lab. And what update we have done in this file? We have updated the network host and we have updated the port, right? If you remember, we have uncommented these values in the elasticsearch.yaml. The next file we have the kibana.yaml, and in the kibana.yaml, if you remember, we have updated three things. First, we uncommented the server.port, then we updated the server.host, and then we have uncommented the elasticsearch.host. So what I did, I copy all these files, right, and do all the stuff which I need to execute at runtime. It doesn't mean that you cannot execute, you cannot update the file at runtime, but I want to avoid that stuff. I just need to make the installation simple. So I have kept all the files in the local machine. Now we have the another file install elk.sh. We will discuss it later. First, let's go to the variable, and the variable is same: AWS region, provider, AMIs, path to public key, path to private key, and the instance and instance username. This is the new variable which we have declared. Let's go to the Elasticsearch create instance.tf, and here we have the create instance.tf. This is the key value pair which is we have already seen. This is the security group which we have created in the earlier lab, right? There's no change, but we have done few change in the create instance. In the last lab, we have seen the code which was present up to the tags. We have seen the AMI which we are taking from the lookup functions, the instance type m4.large, AP South 1A availability zone, the key I'm reading from the above defined variable. VPC security group, I'm defined the security group which I have defined in the same file. And this instances depend on the security group. Then we have the tags. Now we have added few provisioners. See, we have added the provisioners file. And first, what I am doing, I am getting the elasticsearch.yaml from my current directory and putting this file at the temp location on my box. Same I'm doing with the kibana.yaml, and same thing I'm doing with the apache 01.conf. Then we have the another provisioner file that we are picking up the install elk.sh, and we are putting this install elk.sh in the temp file, right? Now, what this will do, we have already learned about it. The file provisioner will copy the file from the source location and paste the file on the destination location on the node. So what this will do, this will copy the Elasticsearch, Kibana, Apache 01 and elasticsearch.sh from the local directory which I have defined over here, and keep this file at a temp directory on the box which we will spin up on the AWS. Then we have the another provisioner remote exec, and inside the remote exec, what I'm doing, I'm providing the executable permission to my install elk.sh which I copied at the temp location. Then we are removing some CR characters. You can also use DOS to Unix command. Then I'm executing this shell file. And how I'm doing it? I'm doing it by making a connection. So we are using the callsec function. We are reading the public IP and the private IP. Type of the connection will be SSH. The user will be the instance.username, and we have the instance.username is Ubuntu. And then we are reading the private key. Private key I have defined inside the variable private path to private key. If you will go to the variable, this is the private key variable. So public key and the private key both are present at these location in my case. In your case, if the private key and the public key at some other location, you need to specify your private key and the public key location over here. So this is the simplest thing we have seen earlier as well, right? We have seen the remote exec, we have seen the file exec, we have seen the user commands as well. Now let's go to the install elk.sh, which is going to install the elk on your box. So over here we have mentioned all these commands which we have used in the earlier lab. See, we are updating the package manager, then upgrading the package manager, installing the Java, reading the Java version, then I'm executing the wget to add the key. putting up the stable package of the Elasticsearch and OSS in the init services, updating the package manager, installing the Elasticsearch. Then I'm putting sleep of 10 second, right? After each installation, I'm putting the sleep of 10 second. I'm putting the sleep so that the execution will work smoothly, right? Sometimes what happen if you don't put some sleep or you will execute the commands back to back, then it may possible some command may fail. So although this script is also not ready for the production use, but this is the script which we can use to install the ELK. If we want to keep this script ready for the production, we need to modify few things as well. We will discuss around it. Then what we are doing, we are moving the elasticsearch.yaml at a location etc elasticsearch elasticsearch.yaml. What is this file? Temp Elasticsearch. This is the file which we have copied with the help of the file provisioner. It means this is my local file. So at runtime, the local file will be placed by the original file so that I will get all the necessary change which I have done inside my local file, like the port and the host and the path logs and the path data. Then I'm starting the Elasticsearch service, verifying that the service is accessible. After that, we are installing the Logstash, again putting the sleep of 10 second, then installing the Kibana, again putting the sleep of 10 second. Similarly, we are replacing the temp Kibana with the original Kibana.yaml, starting the Kibana, then we are putting the apt-get install metric beats, putting sleep of 10 second, starting the beats. Then we are copying the Apache 01 conf and putting up in the conf.t of the logstash, putting the sleep of 10 second and starting the logstash service. So this is the same thing which we have executed in the earlier lab. There is nothing new, just the way of execution is new, but the goal is same and the activity are also same which we have executed in the earlier lab. So let's commit this code, get this code on the machine where you are executing the Terraform, and let's start execution of this code. So I will go to the machine where we are executing the Terraform. So team, here we are on the Terraform machine. Let's go to the directory case study elk demo 2. Before this, you need to execute the git pull. I have already the code available on my box, so I'm not executing the git pull again. Put ls, and you can see over here we have all the files: Apache 01conf, create instance.tf, elasticsearch YAML, install elk.sh, kibana YAML, and variable.tf. Let's execute Terraform init. It will initialize the Terraform plan. It will display the plan of the Terraform. If we will move a bit, then you can see EIP will be deployed, instance will be deployed. The instance will be deployed in AP South 1A. The key is level up key. The machine type is m4.large. Then it is going to deploy the private key. Then it is going to push the key pair, then the security group, right? So these are the four resources which will be created. I will execute Terraform apply, and let's see the Terraform execution. Start creating the resources, and once the resources will be created, it will start execution of your installation file which we have executed with the help of the remote exec. So you can see it is creating my first instance. Let's wait until the instance will be created. So instance creation is still in progress. We have to wait. Now you can see the Terraform is executing the file provisioning, and now it will copy all the files from your local box to the AWS machine. Once the file provisioning will be done, it will create the connection with the machine and start execution of the file which we have defined inside my configuration. See, the connection is being created. Now it will execute the shell file which we have supplied. The shell file execution is started. You can see right now remote exec is executing the shell file. It is updating the package manager. After the package manager update, it will upgrade the package manager. So let's wait. Now it is installing the Java. Once the Java installation will be done, it will verify the Java version and it will start execution of the installation Elasticsearch. So don't worry, once the complete execution will be done, we will go through these logs which are printing on the terminal. You can see it is updating the alternative. Now it is downloading the Elasticsearch. After the download, it will install the Elasticsearch. So now it is unpacking the Elasticsearch 7.10.1. You can see the Elasticsearch is completed. Now it is downloading the Logstash. After the Logstash download, it will install the Logstash and it will move to the Kibana. Unpacking the Logstash. The Logstash is successfully configured. Now it is working on the Kibana. The download of the Kibana is also done and it is unpacking the Kibana.
Kibana service start may take some time, so we have to wait. Now it is adding the Kibana in the system D services, and now it is basically working on the metric beat. The installation is done, and now it is exited with the public IP. Let's do one thing. Let's go to the AWS instance and go to the running instances. Over here we have the running instance. Let's copy this IP and SSH this instance. So I will clear out the console and SSH my instance. Put yes. Let's go to the temp. Put ls and see. Over here we have the terraform.sh and we have the install elk.sh. Right? Rest of the files, the kibana.yaml and elasticsearch.yaml has been moved to the location which we have defined, but we have not moved the install elk.sh. So install elk.sh is still present on the temp location. If you want to verify the other file, let's clear out the console and execute cat etc elasticsearch elasticsearch.yaml, and we don't have the permission. Let's execute this command with sudo. We are getting the changes, like we have modified the port and we have modified the network host. Let's clear out the console and exit out from the AWS machine. Now let's go to the AWS instance again, copy the IP, go to the browser and try to access on port 5601 and see. We are getting our ELK. This is opening the Kibana UI. Let's go to the explore my own, go to the Kibana, visualize and analyze, go to the dashboard or discovery, add the index, and index will be metric beat. Let's put all metric beats over here. Now click on next step, click on timestamp, click on create index pattern. Index pattern is created. Go to the discovery again. So this is the way how we can create the machine, the ELK cluster with the help of the Terraform. Right. So I hope the things are pretty much clear, because we have executed the similar kind of things multiple time in this course. Because we are executing the Terraform M4 large machine, so we need to destroy this cluster so that we will not get the billing from the AWS. So we'll execute the command terraform destroy. Once asked, provide your confirmation, hit enter. So team, this is the way how we can deploy the centralized logging in AWS with the help of the Terraform. I hope you are enjoying this course and you are learning few challenging things over here. If you have any feedback, please share your feedback. We will try to cover the concepts which are missing in this course. And please rate this course, because your reviews are very important for us. That is the public and social proof of the course, that course is providing something relevant information to the student. Thank you team. See you in the next lecture.